tiny speck of light approaches from the deep black of interstellar space, a ghostly green comet drifting into our solar system. This is 3I Atlas, only the third object in history confirmed to have come from outside our solar neighborhood. At first glance, it looks like a regular comet, with a faint halo of gas and dust, but scientists quickly realize this visitor carries secrets from another star. Its chemistry is bizarre, its path is puzzling, and its very presence is rewriting what we know about cosmic wanderers. Over the next few minutes, we'll unravel how this interstellar comet got here and what makes it so extraordinary. If you're finding value in this deep dive, gently tap that like button and subscribe. Tell me in the comments where you're listening from, what time it is there, and what you think is the most compelling anomaly about 3I Atlas. As October 2025 arrived, Comet 3I Atlas plunged into the inner solar system, and the increasing sunlight began to dramatically change the comet's behavior. Telescopes observed that in the weeks leading up to perihelion, late October, the comet's brightness was on the rise. In fact, it brightened more rapidly than anticipated as it neared the sun. This suggested a spike in activity. Perhaps fresh areas of ice were exposed and vigorously sublimating, throwing off gas and dust. Such pre-perihelion outbursts are not unheard of, but they put scientists on alert that 3I Atlas might be volatile. At the same time, something subtle but significant was noted. The comet's color was changing. Initially, with its thick, dusty crust, 3I Atlas had appeared reddish, dominated by sunlight reflected off dust grains. But as it got closer to the sun and heated up, observers reported it was becoming bluer in hue. In astronomical terms, bluer means it was emitting or reflecting relatively more light at shorter wavelengths. This often happens when a comet becomes extremely active. The gas in the coma, which tends to glow blue-green, starts to overpower the yellowish-white light of dust. Essentially, 3I Atlas's coma was transitioning from dust-dominated to gas-dominated, indicating an outpouring of new volatiles. In early November 2025, shortly after perihelion, an advanced telescope in Arizona captured 3I Atlas, shining with a ghostly green coma. The image, taken with specialized filters, shows a diffuse emerald haze surrounding a bright core. This green glow is the result of diatomic carbon, C2, gas and other molecules fluorescing under the sun's ultraviolet light. It's the same mechanism that makes many comets appear green when they come close to the sun. UV radiation breaks apart carbon-bearing molecules in the coma, and some of the fragments, like C2, emit a greenish light. So, the comet didn't literally turn green overnight in a mysterious way. Rather, it was now so active that certain gas emissions became prominent to our detectors. Astrophotographers Michael Yeager and Gerald Raymond, among others, even captured images during a late October lunar eclipse that hinted at this color change, though it took sensitive instruments to confirm it. The green hue tells scientists that 3I Atlas's coma contained lots of broken-up carbon molecules, consistent with the idea that its surface organics were being vaporized in large quantities. Interestingly, around the time of perihelion, some images made it seem as if 3I Atlas had lost its tail, appearing as just a round coma with no obvious streak. This led to brief speculation. Had something happened to the comet's tail? The reality was more mundane and reassuring. The tail was still there, but due to our viewing geometry, it was almost directly behind the comet's head from Earth's perspective. Essentially, we were looking down the tail's length, making it appear foreshortened and faint. In one November image by astronomer Chi-Cheng Zhang, the coma looked slightly asymmetric, a hint that the dust tail was pointing away and a bit to one side, nearly hidden from view. As the comet and Earth's relative positions shifted, the tail became visible again. There was nothing physically wrong with 3I Atlas. It was an optical illusion of alignment in space. The show wasn't over once 3I Atlas swung around the Sunday. On the contrary, having survived perihelion at 1.36 AU, the comet emerged energized. Observers in early November reported that the comet now displayed multiple distinct jets in its coma. Jets occur when specific areas of the comet's nucleus vent gas and dust in narrow streams, like fissures or vents on the surface acting as cosmic geysers. Because 3I Atlas likely has an irregular shape and heterogeneous surface, different patches of ice can heat up and outgas at different times, producing these fan-like plumes. Here is an enhanced black and white image from the 8th of November 2025, showing 3I Atlas with multiple jets emanating from its nucleus. The comet's core is the dark spot in the center, and faint linear features, indicated by white arrows, can be seen radiating outward. These are the jets or spokes of material in the coma. This complex tail structure tells us the comet was rotating and releasing material from several active regions on its surface. It's a stunning confirmation that, despite its interstellar origin, 3I Atlas is dynamically behaving like many solar system comets do when they get warm, shedding its icy layers in dramatic fashion. Crucially, during all this heightened activity, 3I Atlas stayed intact. Many researchers had been nervously watching for any signs of the nucleus breaking apart, a fate that befell the previous interstellar comet 2I, Borisov, which began to fragment after passing the Sun. But as of late, 2025, no fragmentation of 3I Atlas has been detected. Its brightness changes, while rapid, were consistent with surges in outgassing rather than a catastrophic breakup. The comet's nucleus, perhaps protected by that tough irradiated crust, withstood the solar heating admirably. In fact, by some accounts, 3I Atlas was a more massive object than Borisov, which might also contribute to its resilience. Larger comets can hold together better. All these transformations, the color shifts, the jets, the coma's growth, provided rich data for scientists. However, they also lit a fire under the imagination of the public and even some scientists. If 3I Atlas was this weird and active, could there be something more to it than meets the eye? As news spread of the comet's unusual behavior, speculation began to swirl about the true nature of this interstellar visitor. The comet's dramatic behavior near the Sun led some to question, was everything we observed purely natural? Or could 3I Atlas be something more than just a comet? In the next section, we'll separate sensational speculation from scientific reality. As telescopes collected light from 3I Atlas, the first big surprise came from its composition. In mid-2025, the James Webb Space Telescope, JWST, captured the comet's spectrum, and the readings were nothing short of remarkable. They revealed that 3I Atlas is unusually rich in carbon dioxide, CO2, far richer than any typical comet from our solar system. In fact, one analysis found that CO2 was about 7.6 times more abundant than water in this comet's outgassed vapor. To put that in perspective, for most comets we know, water is the dominant volatile ice, with CO2 and carbon monoxide only as minor components. But 3I Atlas turned that trend on its head. CO2 outgassing vastly exceeded H2O. Statistically, it was an extreme outlier, roughly 4-5 sigma, above the usual cometary range for CO2-H2O ratio, meaning this is among the highest CO2 levels ever recorded in a comet's coma. Along with that, a substantial amount of carbon monoxide, NOx, was detected around 1.6 times the water output, as were smaller traces of familiar gases like water vapor, a little bit of carbonyl sulfide, and others. This bizarre chemistry immediately set 3I Atlas apart. Such a high CO2 content suggested that either it formed in an extremely cold environment where CO2 ice could accumulate, or something happened during its long interstellar voyage to alter its makeup. Scientists lean toward the latter explanation. Why? Because alongside the gas data, JWST and other observatories noted that the comet's material reflected a lot of red light, giving it a redder than usual color, a red spectral slope. Meanwhile, Earth-based telescopes, like the European Southern Observatory's VLT, picked up emission from cyanide, gas and even vaporized nickel coming from the comet. Interestingly, those particular ingredients were comparable to normal comets in our solar system. So, 3I Atlas was both familiar and alien. It had some typical comet gases, like CN, in normal proportions, yet an overabundance of others, CO, II, CO, that defied expectation. Researchers put these clues together and proposed a compelling theory. The key to the mystery might lie in the comet's age and interstellar exposure. If 3I Atlas has been traveling between the stars for millions or billions of years, it would have been bombarded by galactic cosmic rays, high-energy radiation that permeates interstellar space. Over such immense timescales, cosmic rays could penetrate and chemically alter the comet's outer layers. Laboratory experiments show that when cosmic rays strike ices like CO, carbon monoxide, they can trigger reactions that produce CO2 and also create dark, complex carbon-rich compounds, essentially an organic crust, N. It's a bit like slow cooking. Over eons, a comet's surface might get baked by radiation into a refractory crust. While some CO ice is converted into new CO, 2 ice trapped in that layer. This appears to be exactly what happened to 3I Atlas. The evidence of a red crust from the red spectral slope and the excess CO2 points to a surface heavily processed by cosmic rays. In fact, scientists estimate that perhaps the outer 15-20 meters of the comet's nucleus have been altered in this way, and that is the portion currently shedding material into space. What we're seeing in 3I Atlas's glowing coma right now is likely only the processed outer skin of the object, not the pristine ices buried deeper. All the CO2 and complex organics could be coming from this radiation-aged mantle. The original unaltered ices from the comet's formation, rich in water, etc., might still lie untouched in the core, not yet reached by the sun's heat. If true, that means 3I Atlas is venting its history of interstellar travel rather than the pure fingerprint of its birth environment, a wild realization that challenges our hope of easily sampling other star systems as night material. In scientific terms, this is a potential paradigm shift. Long-duration interstellar objects might mostly show us their post-journey weathering instead of their primordial state. All of this ties into just how old 3I Atlas might be. By tracing its incoming trajectory and speed through the galaxy, astronomers suspect it could hail from the Milky Way's thick disk population of stars. If so, it might have formed as long as 7 billion years ago, making it perhaps 3 billion years older than our solar system itself. Indeed, some have called it possibly the oldest comet ever observed. This ancient origin story fits with the cosmic ray processing idea. An object billions of years old would have wandered the galaxy long enough to build up that thick, irradiated crust we now see. In essence, 3I Atlas is like a time-worn messenger. It was likely born around a far-off star in a primordial era, then ejected into the void and left to roam. Over unfathomable ages, its surface chemistry was sculpted by the galaxy's radiation. Now it arrives at our doorstep, looking like a comet, but carrying a composition that whispers of that lonely journey. Scientists are marveling at this. It's a chance to study both an alien comet and the effects of deep time on small bodies. Yet, the story was not complete. As 3I Atlas drew closer to the sun, something unexpected happened. The ancient, quiet comet began to stir with activity, undergoing visible changes that added new twists to the mystery. Astronomers first spotted this interstellar intruder on the 1st of July 2025, using the Atlas Survey Telescope in Chile. It appeared as a dim, fast-moving dot against the stars, initially designated C 2025N1 Atlas. It didn't take long for experts to determine something astonishing. This object was not bound to the sun at all. Its orbit wasn't an ellipse like ordinary comets, but an open hyperbolic trajectory, meaning it's just passing through, on a one-way ticket out of the solar system. In fact, when extrapolated into the past, the path of 3I Atlas clearly originates far beyond the outermost planets. By time it entered the solar system, 3I Atlas was barreling forward at about 58 kilometers per second, relative to the sun, far too fast for the sun's gravity to capture it permanently. This unmistakable signature earned it the designation 3I, marking it as the third confirmed interstellar object, after 1I, ʻOumuamua in 2017, and 2I, Borisov in 2019. From day permented, 1, scientists knew 3I Atlas posed no threat to Earth. It was on track to remain at least 1.8 AU away, nearly twice the Earth-Sun distance, at closest approach. In fact, it wouldn't even get as close to us as Mars's orbit. Instead, this visitor would skim through the inner solar system peacefully. On the 29th of October 2025, it reached perihelion, its nearest point to the Sun, at about 1.36 AU, just inside the orbit of Mars. Even then, it stayed a very comfortable 203 million km from the Sun. What got everyone excited was not any danger, but the opportunity. Unlike ʻOumuamua, which was spotted only after it had swung past the Sun and was heading out, Comet 3I Atlas was discovered well before its closest approach. This gave astronomers a rare chance to organize a global observing campaign. Telescopes around the world and in space turned to watch. The Hubble Space Telescope snapped a sharp image in July. NASA's James Webb Space Telescope prepared to take its spectrum, and even spacecraft around Mars got ready to observe the comet during a flyby opportunity. Right away, analysts noticed something curious about 3I Atlas's approach. It seemed to come from a very unexpected direction. By tracing its path across the sky, they found it came out of the southern celestial hemisphere, in the direction of the constellation Sagittarius, roughly toward the galactic center. This was almost the opposite direction to the Sun's motion through the galaxy, the solar apex in the north, defying some expectations. In other words, our solar system essentially overtook this comet from behind. Such an origin hints that 3I Atlas may have spent eons drifting in the Milky Way's outer regions before fate sent it our way. As the comet drew nearer, observers could already see it was active. A soft, fuzzy coma, a cloud of gas and dust formed around its nucleus, even when it was still beyond 3 AU from the Sun. Clearly, 3I Atlas carried plenty of volatile ices that vaporized to create a halo, a telltale sign of a genuine comet. Estimates of its nucleus size were rough, but Hubble data suggested a small body, likely less than 1 kilometer across, a few hundred meters wide. That's similar in scale to many known comets, though the coma it produced was enormous, hundreds of thousands of kilometers wide. It soon became apparent that, unlike the odd rock ʻOumuamua, which never showed a coma, 3I Atlas behaves much more like a traditional comet, just one that hails from another star. But as routine as it first appeared, its inner makeup was anything but ordinary. Scientists were about to discover that this comet's chemistry is profoundly strange, raising new questions about how it formed and how it survived the long journey to our solar system. But once the data started coming in, 3I Atlas proved to be no ordinary comet at all, revealing chemical secrets that left astronomers' teleses astonished. It has almost become a tradition. When an interstellar object grabs headlines, talk of aliens isn't far behind. In the case of the first interstellar object, ʻOumuamua, its puzzling properties, like an unexpected acceleration and odd shape, led a few researchers to propose it might be artificial, perhaps a light sail or probe from another civilization. Those claims remained unproven, but they set the stage. So when 3I Atlas started showing its own anomalies, speculative theories cropped up again. One prominent voice, Harvard astronomer Avi Loeb, publicly discussed 3I Atlas and enumerated a list of curious observations, 10 anomalies. By his count, these included the comet's unusual trajectory, approaching opposite the solar apex, its unexpected rapid brightening and color changes, the extreme CO2 excess, and the presence of what he interpreted as a set of jets that possibly caused slight deviations in its path. Loeb suggested that while 3I Atlas is most likely a comet, one should not dismiss a more exotic possibility. Could it be some kind of extraterrestrial technological object? He mused that the comet's behavior, for instance, venting lots of gas in a way that might appear as controlled bursts, could be analogous to a spacecraft revving an engine, at least in a thought experiment. Such ideas made headlines and stirred debate on social media, echoing the alien speculation that surrounded ʻOumuamua. It's important to stress, however, that extraordinary claims require extraordinary evidence, and so far, all of 3I Atlas's peculiarities have conventional explanations. Let's revisit those anomalies with a scientific lens. Approach trajectory. Yes, 3I Atlas came from an odd angle, the southern sky, roughly from the galactic center's direction, but nothing about that screams artificial. Interstellar objects can arrive from any direction. In fact, the distribution of stars and the debris in our galaxy is such that visitors could just as easily come from above or below the plane of the solar system. The surprise was mostly because both prior interstellar objects came from northerly directions, so 3I Atlas's route was a reminder not to generalize from a sample of 2. It's a true outsider in origin, but not inexplicable. It simply reflects the random orbits of cometary bodies in the Milky Way. High speed and hyperbolic path. 3I Atlas's high velocity, 58 kilometers per second, and hyperbolic orbit are exactly what one would expect for an interstellar interloper. It did not gain that speed within our solar system. No planets gave it a gravitational slingshot or anything. Instead, it arrived preloaded with enough velocity to escape the sun's grip, a clear sign of foreign origin, but not evidence of propulsion. Gravity, not engines, accelerated it, likely an ejection event in its home system, sent it flying long ago. There's no sign of maneuvers or course, changes that aren't explainable by normal comet outgassing forces or gravity, chemical oddities, CO2, and more. We covered how the extreme CO2 enrichment can be explained by cosmic ray processing of 3I Atlas's ices over time. While this is indeed an anomaly relative to solar system comets, it's a natural anomaly, a product of an environment, interstellar space, that our comets haven't experienced to the same degree. There's no need to invoke alien tampering to account for it. Moreover, the fact that 3I Atlas has plenty of familiar cometary substances, water, CN, dust, etc., in addition to the exotic ratios, strongly supports that it is made of normal matter from a planetary system, not some advanced construction. Brightness jumps and jets. Comets are notorious for unpredictable outbursts. 3I Atlas is pre-perihelion. Brightening and multiple jets are spectacular, but not beyond the realm of known comet physics. For instance, Comet 46P, Wirtanen in our solar system, had episodes of sudden brightening, and many comets show jets when high-resolution images are taken. The jets on 3I Atlas were observed at roughly the expected time, near perihelion, when solar heating peaked. Rather than thrusters being fired, what likely happened is that subsurface pockets of volatile ice ruptured, releasing pent-up gas in narrow streams. This can even nudge a comet's trajectory slightly, a phenomenon known as non-gravitational acceleration, which might be one of the anomalies noted. But again, that's a well-documented cometary effect, not evidence of control. Color changes. The shift from red to blue-green hue was intriguing, but ultimately aligns with the chemistry. As mentioned, the rise in cyanide, An, and other gases can cause a comet's observed color to skew blueward. In fact, Loeb himself acknowledged that the steep increase in CN production around perihelion could be linked to the color shift. So, even one of the biggest champions of considering other explanations notes a plausible mundane cause for this particular anomaly. In summary, while it's fun and important to ask, what if? Most astronomers remain confident that 3I-ATLAS is just a comet. An extremely interesting comet, but not an alien spacecraft in disguise. A Live Science article put it succinctly: a lot of buzz about aliens surrounded 3I Atlas. Even though most astronomers are confident that the interstellar visitor is a comet from an unknown star system, the scientific consensus is grounded in the data. Nothing observed about 3I Atlas violates physical expectations for a natural object. It's carrying a chemical record of cosmic processes, not a message from ET. Still, the debate itself highlights something valuable. As Professor Loeb pointed out, science thrives on investigating the unknown with an open mind. By listing anomalies and proposing hypotheses, even far-fetched ones, scientists ensure that we don't take things for granted. In the case of 3I Atlas, these discussions have spurred even more observations, because if there were anything truly odd at play, we'd want as much evidence as possible to catch it. Loeb and others eagerly await new data, as the comet comes closest to Earth in December 2025. Around the 19th of December 2025, 3I Atlas will be about 1.8 AU from Earth. Not exactly close in human terms, but close enough for telescopes to get perhaps their best look at the comet's coma and tail. There is hope that with the comet in a post-perihelion, active state, any lingering questions like its rotation rate, precise outgassing pattern, or detailed composition can be answered then. And so, the sensational hypotheses will meet the hard test of data. If there's one thing everyone agrees on, it's that more observations are key. Missions and observatories are seizing the chance. Even the European Space Agency's JUICE spacecraft, currently in the outer solar system, has been scheduled to take a peek at 3I Atlas during November 2025, while the Comet is in an active phase. The data from JUICE and other observatories will trickle in over the next few months, allowing scientists to further refine their understanding. With speculation addressed, we return to what 3I Atlas truly represents. In the final section, we'll reflect on the broader significance of this comet's journey and what it has taught us about our cosmic neighborhood and beyond. In the end, the saga of 3I Atlas is a story of connections. It links us to a place beyond our sun, to times long before Earth existed, and to the dynamic processes that shape worlds across the galaxy. To understand how it entered our solar system, we must imagine its journey from the very beginning. Picture a young star somewhere in the Milky Way billions of years ago. Around that star, a cloud of gas, dust, and ice coalesced into comets and planets. 3I Atlas was likely one such comet, quietly orbiting its parent star in the frigid outer reaches. Then, a gravitational perturbation occurred, perhaps a passing star in that star's cluster, or a giant planet migrating. And this little comet was flung out of its home system. From that moment on, it became an interstellar nomad. For ages, 3I Atlas drifted in the darkness between stars. Without a sun to warm it, it remained frozen and inert, all the while being peppered by cosmic rays that slowly altered its surface. It carried on like this for millions upon millions of years. The Milky Way's rotation and the motions of stars eventually set it on a course that intersected the path of our solar system. When it finally neared our sun, it was like a castaway finally approaching an island shore. The sun's gravity began to tug on it, accelerating it to tremendous speed at the outer boundary of our solar system. By the time it was detectable by our surveys, 3I Atlas was already screaming inwards on that hyperbolic trajectory we computed, a trajectory only possible because it originated outside no comet, born in our solar system and gently perturbed, could attain an eccentricity of 6.1 and such high velocity. In simpler terms, it entered our solar system because it was unbound and just happened to be passing by. The sun's gravity bent its path into a steep curve but couldn't capture it. 3I Atlas was moving too fast and on too open a course to do anything but briefly visit before continuing on its way. Now that it has rounded the sun, 3I Atlas is headed back out to interstellar space. It's currently moving on an outbound leg that will take it beyond the planets, eventually back into the cosmic gulf from which it came. It will make its closest approach to Earth in December 2025. But close is relative. At 1.8 AU, it will still appear as just a faint speck in our telescopes. After that, it will fade away for good as it recedes. Barring an unlikely future space mission to chase it, 3I Atlas will become another lost traveler among the stars. Perhaps it will even find its way into another planetary system, tens of millions of years from now, extending its odyssey. From this one comet, scientists have gleaned a trove of insights. We learned that not all comets are alike. Some can have chemistry vastly different from those in our solar system, reflecting different origins or long exposures to space. We saw direct evidence that cosmic rays can age and transform small bodies over time, which has big implications for how we interpret any interstellar objects we might capture or sample in the future. We confirmed that interstellar comets can be active and even larger than the first ones we saw, which is encouraging for detectability. 3. Atlas was bright enough that even some amateur astronomers with good equipment have photographed it. In fact, its brightness and longevity, staying observable for many months, have made it a best-case scenario for study, especially compared to fleeting ʻOumuamua. We also saw the value of being prepared. Observatories from Earth, from Mars Orbit, Mars Express, and TGO, and even a spacecraft en route to Jupiter, Marsall, coordinated to observe this comet. It's a dry run for future efforts. Agencies like ESA and NASA are even contemplating dedicated missions. For example, Comet Interceptor, planned for 2029, which will wait in space to intercept an incoming comet, possibly even an interstellar one. The diversity between ʻOumuamua, Borisov, and Atlas has shown us that each interstellar visitor is unique. If we could visit one up close with a probe, who knows what we might find? As we bid farewell to 3I Atlas, we're left with a sense of perspective. This comet's journey underscores that our solar system is not an island, it's part of a vast galactic ecosystem. From time to time, pieces of other worlds wander through. Most are probably like 3I Atlas, natural relics of planet formation around distant stars. But the only way to know that for sure is to keep looking, keep analysing, and stay curious. After all, not long ago the very idea of interstellar objects was mostly theoretical. Now we've met 3 in just the span of 8 years. How many more lurk out there, waiting to be discovered? The story of how 3I Atlas entered our solar system is, at its heart, a story of chance and time. Chance, because it had to be on just the right trajectory to encounter our sun's vicinity. Time, because it spent uncounted ages on its cosmic cruise. It reminds us that our sun, too, likely ejects comets into the galaxy. Perhaps one day, a comet from our Oort cloud will become someone else's interstellar object 1I. There's a poetic symmetry in that. Each interstellar comet is a bit of one star's history, offered up to other star systems. As 3I Atlas now recedes into the black, we reflect on what a privilege it has been to witness it. Humanity got a close look at a piece of the galactic center's fringe, an emissary from a time and place beyond our own. Its green glow, its ancient crust, its fiery jets by the sun, all will be gone from view soon, but they have expanded our knowledge and our imagination. The cosmos is full of wonders, and every so often, one drops by unannounced. In the quiet that follows 3I Atlas's departure, we can't help but gaze at the stars with renewed wonder. What other marvels from the deep galactic sea are already on their way toward us? And when the next one arrives, what new secrets will it whisper about the worlds it once knew? The story isn't ending, it's just beginning, with 3I Atlas having shown us that the mysteries of the universe are closer than we think. Sometimes as close as a small comet drifting through the dawn sky. The farther 3I Atlas drifts, the quieter it becomes. Its glow, once visible even to modest telescopes, now fades into the cosmic background. Yet, its trajectory is known with exquisite precision. Astronomers can trace its future path for centuries to come. If left undisturbed, this object will pass beyond the gravitational reach of the sun entirely, slipping back into the interstellar void that once cradled it. And out there, in that deep galactic dark, it will keep moving endlessly, silently across a landscape that has no up or down, no center, no boundary. The stars themselves will drift while 3I Atlas sails between them, carrying the molecular memory of its birth. It will pass clouds of hydrogen, regions of dust lit by ultraviolet light from newborn stars, and the invisible bow shocks that ripple through the Milky Way's arms. Once every few tens of millions of years, it might cross the outskirts of another star's domain. If the odds align perfectly, that star's gravity could pull it inward once again, a second act, a second chance to glow. But most likely, 3I Atlas will simply travel on, unobserved and untouched, a relic of a time when its home star was still young. What makes this story so profound isn't just where it's going, it's what it already endured. When we say 3I Atlas came from another star, we mean that literally, it was ejected. Somewhere, billions of years ago, a planetary system was forming. In its frozen outskirts, the analogue of our Oort cloud, trillions of icy bodies orbited in deep cold, left over from the chaotic birth of planets. Perhaps one of those planets migrated outward, disrupting the gentle ballet of these icy remnants. One comet, the one we now call 3I Atlas, strayed too close. A gravitational tug from that planet flung it outward, far beyond the system's edge. There, the star's gravity could no longer hold it. One final nudge, maybe from a passing star or the tidal pull of the galactic disk, sent it hurtling into interstellar space. It's a violent way to begin an eternity. For most comets, such an ejection means exile. They become nomads forever, frozen and forgotten. But for us, that same exile is a gift. Without it, 3I Atlas would have remained invisible, forever locked in a distant system we'd never know. For billions of years, it wandered. Imagine the emptiness of its journey. No sunlight, no heat, only the soft impact of cosmic rays. These rays, particles from supernovae and black hole jets, bombarded the comet's surface, atom by atom, rearranging its chemistry. Hydrogen was stripped away, oxygen bound with carbon to form carbon dioxide, and a thin layer of organic tar built up over time. Slowly the comet darkened, turning a deep reddish brown, a skin baked by radiation across eons. This process, called space weathering, doesn't just scar, it preserves. Under that crust, the ices remained intact. Water, carbon monoxide, ammonia, the ingredients of life. Locked away in a frozen archive, 3I Atlas, by the time it reached our solar system, was not merely a visitor. It was a time capsule carrying chemical fingerprints from a planetary nursery that predated Earth itself. Scientists studying its composition suspect it may have formed around a red dwarf star, one of the galaxy's most common stellar types. Such stars burn dimly but live for trillions of years, allowing planetary systems to evolve in slow motion. If that's true, 3I Atlas may have originated in a system utterly unlike ours, smaller, colder, bathed in a dull crimson light instead of the golden warmth of the Sunday. And now, that same fragment from another star's youth has briefly crossed our path long enough for us to read its story. Every reading from telescopes adds another line to that story. The high carbon dioxide levels hint at freezing formation conditions, perhaps near 30 to 40 Kelvin, much colder than where most solar system comets formed. The presence of cyanide gas and trace nickel vapors matches what we see in comets here, suggesting certain universal recipes exist for building icy bodies throughout the galaxy. But other clues hint at differences. The ratios of CO2, CO, and water are off by orders of magnitude. The dust grains ejected from the comet are unusually fine micron-sized silicates and amorphous carbon. They scatter sunlight differently, giving the coma that eerie emerald tint, and as sunlight struck its surface for the first time in millions of years, those ices erupted. It's poetic. The same light that once ignited life on Earth also awakened this alien traveler. Jets burst from fissures in its crust, spraying gas and dust into space. For a few weeks, 3I Atlas was alive again, glowing, breathing, shedding its ancient skin in the sun's embrace. Astronomers captured these moments with awe. To them, each image wasn't just a photograph. It was a page from a cosmic autobiography being written in real time. Some likened it to seeing an ember from another campfire drift into ours. There's also the question of how rare this truly is. For decades, astronomers believed that interstellar objects were rare, 1 in a million phenomena. But with improved sky surveys and automated detection systems like Atlas, Pan-STARRS, and Vera Rubin Observatory, that assumption has changed. Now we realize space is full of travelers, like 3I Atlas. At any given moment, thousands may be crossing through our solar system, most too faint to detect. Statistically, a new interstellar object should pass within Jupiter's orbit roughly every few years. 3I Atlas is simply one we happen to see. Each one we find offers a chance to rewrite what we know about planetary systems. In a way, interstellar comets are ambassadors, fragments of other worlds that come to us uninvited, bearing gifts of data, chemistry, and cosmic perspective. They remind us that our solar system is not a sealed bubble, but part of a galactic network of exchange. Dust, rocks, comets, even microbes, potentially can leap between stars. The building blocks of life may not be confined to any single system, but shared, recycled, and dispersed across the Milky Way. So, when we study 3I Atlas, we're not just studying one comet, we're peering into the grand circulation of matter and memory that binds the galaxy together. And yet, there's something profoundly humbling about it too, because in all our equations, we can model trajectories, compute orbits, measure spectra, but we cannot truly fathom the scale of what this comet has seen. It may have drifted past supernova remnants, glowing with ghostly X-rays. It may have skimmed through molecular clouds where new stars were being born. It may have passed through the galactic plane countless times, buffeted by tidal waves of gravity and radiation. For billions of years, it has existed in a silence beyond imagination. Then, for a fleeting instant, just a few months in human time, it crossed paths with us, and in that instant, it gave us a mirror. It reminded us that our sun, too, is a traveler orbiting the Milky Way once every 230 million years, carrying Earth and all its life through the cosmic sea. When we look at 3I, Atlas, we see what we might someday become. A fragment of a forgotten system, wandering among strangers, waiting for another civilization to notice. But this is not the end of the story, only a pause. Astronomers have already begun comparing 3I, Atlas, with data from the upcoming Vera Rubin Observatory, whose ultra-wide camera will scan the sky every night, capable of detecting thousands of new objects each year. Some scientists even propose that future missions, like the Comet interceptor, could one day meet an interstellar object mid-flight to sample it, photograph it, maybe even bring a piece home. Imagine that, a spacecraft chasing a comet not from our solar system, but from another star entirely, collecting its dust and ices, measuring its isotopes, learning, firsthand, what distant worlds are made of. It would be the first physical contact between two star systems, not through radio waves, but through matter, a handshake across light years. And it all begins with discoveries like this one, with 3I, Atlas. When scientists point their telescopes toward objects like 3I, Atlas, they're not just looking outward, they're looking backward in time. Every particle of dust that escaped this comet carries a memory of a place we'll never visit, the temperature, pressure, and chemistry of a world born around another sun. By analyzing the ratios of isotopes, oxygen 1:8 to oxygen 1:6, deuterium to hydrogen, we decode the fingerprints of its origin. Each ratio is like a line of poetry in a foreign language, telling us about the cradle of its birth. The data from Webb and ground observatories already hint that 3I, Atlas, may have formed in an extremely cold, distant region of its home system, perhaps in the twilight between starlight and interstellar night. The high concentration of CO2, the faint traces of carbonyl sulfide, the subtle red tint of its dust all point to a place far from any warming sun. Out there, molecules don't move freely, they crawl. Chemistry proceeds in slow motion. Atoms meet rarely, but when they do, they lock together in bonds that can last for billions of years. That's what makes these comets such pristine time capsules. They preserve the very first experiments of a young universe, trying to learn how to build complex things. And that's why interstellar comets matter more than most people realize. They are cosmic couriers, carrying information that no telescope, however powerful, can capture from afar. When 3I, Atlas, crossed into our solar system, it wasn't simply entering new territory, it was crossing a frontier of knowledge. Until just a few years ago, humanity had never confirmed that solid objects from another star could reach us. We assumed they could, mathematically, but we had no evidence. Then came ʻOumuamua in 2017, Borisov in 2019, and now Atlas. 3 messengers in less than a decade. This sudden burst of discovery forced astronomers to reconsider. Perhaps our galaxy is swarming with interstellar debris. The planetary system births not only worlds but wanderers, millions of them, ejected into the dark. Together, they form a hidden network of travelers moving between stars. 3I, Atlas isn't an anomaly. It's part of a galactic conversation that has been going on for billions of years. And in that conversation, we might even be participants. For every comet that enters our solar system, countless others leave it. Gravitational nudges from Jupiter or Neptune send them drifting outward, joining the great diaspora of ice and dust. Somewhere out there, perhaps another civilization is staring through their telescopes right now, seeing a faint streak in the sky, an interstellar visitor from our own sun, and wondering the same questions we asked tonight. When you think about it that way, 3I, Atlas, becomes more than a comet. It becomes a mirror of fate, because what we see in it is the destiny of all small worlds, to wander, to change, to fade, and to return. Every atom within it was once part of something larger, a nebula, a planetesimal, maybe even a moon that shattered. Now those atoms drift freely, just as the atoms that make us were once fused in the hearts of long-dead stars. The same cosmic winds that propelled this comet also scatter the seeds of life. And there's a philosophical echo here. In a universe that recycles itself endlessly, perhaps we are the consciousness of comets, the brief, self-aware phase of matter, learning to look back at the systems that birthed it. When we send probes into the outer solar system, when we study 3I, Atlas's spectra, we're continuing the journey it began. We are the curious side of the same cosmic story. As it moves farther away, its velocity is still astonishing, tens of kilometers per second. That means every minute, it travels farther than the distance between New York and Tokyo. Every hour, it could cross the orbit of the Moon. In a single year, it will have left the realm of Jupiter. In a century, it will be beyond the Kuiper belt. Beyond that, its path leads into the void between the stars, where even sunlight is a rumor, and temperatures hover just above absolute zero. Out there, time stretches. The distinction between now and later loses meaning. For 3I, Atlas, 1 million years may pass before it encounters another star. Maybe it never will. Maybe it will drift for the entire remaining lifespan of the Milky Way. Or maybe, in some distant epoch, when our sun has long cooled and Earth is only a frozen relic, another civilization will detect it, its orbit faintly altered by the galactic tide, and realize that they're not alone in receiving such messengers. And in that distant future, will they ask the same question we did? How did it get here? Even now, there's an almost sacred humility in that question. It's the same curiosity that led ancient people to watch comets cross their skies, wondering whether they were omens or messages from the gods. In truth, they were messages, just not from gods, but from the cosmos itself. Messages written not in words, but in light, motion, and chemistry. Modern astronomy has translated that language. We can read the isotopic codes, decode the trajectories, simulate the gravitational dances that send such objects our way. But what science adds in precision, it doesn't take away in wonder, because every new piece of data still whispers the same ancient truth. We are part of a universe that talks to itself through the movement of matter. 3I, Atlas, is one of those syllables, a fleeting spark in a sentence, that began before life existed and will continue long after it ends. And so, as it fades, the instruments that once tracked it will move on to other targets. The scientists will archive their data. The observatories will point toward the next anomaly. But somewhere in that vast archive, in the hum of servers and the glow of spectral graphs, will remain the record of this moment, a digital fossil of our encounter with an interstellar traveler. Generations from now, when future astronomers look back on this era, they'll see it as the beginning of something profound, the moment humanity realized it could study not just its own solar system, but the wider galaxy directly. They'll trace the lineage of interstellar astronomy to these years, to these comets, to the humble survey telescopes that first noticed a faint moving dot and thought, that doesn't belong here. That thought it doesn't belong here is what drives every frontier forward. And yet, maybe belonging isn't the right word at all. Because when 3I, Atlas, entered our solar system, it became part of it. For a brief time, its atoms mingled with ours, some of its dust settling on our atmosphere, some of its light absorbed by our instruments, some of its particles caught in our magnetosphere. The boundary between us and it dissolved, as all boundaries eventually do, in a universe built from the same stardust. Perhaps the lesson 3I, Atlas leaves us isn't about how it entered our solar system, but how it entered our story. It reminds us that everything, everywhere, eventually connects. The stars, the comets, the minds that study them. We are not separate observers looking at the cosmos from the outside. We are pieces of it looking inward at ourselves. There's a quiet poetry in how the universe recycles itself. Every atom in 3I, Atlas, has lived many lives before this one. Long before it was a comet, those atoms drifted in a cloud of gas and dust surrounding a newborn star. Before that, they were scattered remnants of older suns that had exploded, seeding the galaxy with heavy elements. Each new generation of stars inherits the ashes of the last. When we look at 3I, Atlas, we are, in a sense, watching stellar memory take shape. Its ice is ancient hydrogen and oxygen. Its dust is forged from the silicon and carbon of dead stars. Even its glowing green coma, The light that caught our cameras and imaginations comes from molecules that were once bound inside long-gone worlds. So when astronomers say that comets hold the building blocks of life, they're being literal. The organic compounds found in these icy bodies, methane, formaldehyde, amino acid, precursors, are the same molecules that seeded the early Earth. Every interstellar comet that wanders into a planetary system carries with it the potential to restart that process somewhere new. The same chemistry that once produced us could someday reappear elsewhere because of travelers like this. It's hard not to imagine what the homeworld of 3I, Atlas, might have been like. Did it orbit a single small sun? Or was it part of a binary system where two stars cast twin shadows across frozen plains? Did it share space with giant planets? Or drift among hundreds of smaller icy worlds? We may never know, but through its chemistry and motion, we can infer pieces of that lost environment. If it truly originated near a red dwarf star, then its cradle was likely a quiet, dim system, a world of endless dusk. Around such stars, comets form farther out, beyond the reach of heat, where even carbon monoxide can freeze. The ices that make up 3I, Atlas, were probably laid down grain by grain in a slow accretion disk, colder than anything we can to reproduce on Earth. That makes its survival remarkable. For billions of years, it remained intact, even as cosmic rays reshaped its surface. The fact that it still exists at all is a small miracle of persistence. Persistence. That word feels human, but it belongs to comets too. They endure, they return, they leave behind trails that outlive them. In a way, humanity is only now beginning to mirror that same persistence on a cosmic scale. Our radio waves have already traveled farther than Pluto. Our probes, Voyager, Pioneer, New Horizons, are our own artificial comets, unbound from the sun, wandering into the void. Like 3I, Atlas, they will outlast us. Someday, eons from now, they may even pass another star and be noticed by another civilization. Imagine that scene. A distant species scanning the sky, discovering a metallic object moving on a hyperbolic path, its orbit defying capture. They would calculate its speed, trace its trajectory, and realize this thing came from another system. They'd point their instruments toward it, take spectra, and maybe, just maybe, find traces of us, the faint chemical echoes of our probe's alloys, or the tiny engraving of a golden record. At that moment, they would feel the same wonder we feel now about 3I, Atlas, the wonder of connection across the impossible. Every discovery like this forces us to think differently about the universe's boundaries. Once, we thought the solar system was everything. Then we learned it was one of billions. Now, with interstellar comets, we realize that the borders between systems aren't walls at all. They're currents, like the flows of a vast ocean. Comets, asteroids, even microscopic grains of dust drift along those currents, weaving the galaxy into a single living structure. And if matter moves freely between stars, maybe information does too. Not messages in the sense of language, but in the structure of atoms themselves in ratios, isotopes, and the subtle imbalances that record the physics of their birth. Each comet, each rock, is a data packet in the grand communication system of the Milky Way. When we decode the story of 3I, Atlas, we are listening to the voice of the cosmos, slow, faint, but unbroken. Somewhere in the faint blue light of dawn, when the last observatory tracking it switched off its sensors, 3I, Atlas slipped beyond measurable reach. Astronomers marked the coordinates, filed the final observation report, and closed their logs. But that wasn't an ending. It was a transition. The comet left the human record and rejoined the unrecorded universe. In the coming centuries, it will cross the heliopause, the invisible frontier, where the sun's influence fades and the interstellar medium begins. There, it will encounter particles ejected from supernovae, fields of magnetic turbulence, the faint hum of radio emission from the galaxy itself. Each of these interactions will leave microscopic marks on its surface, atomic scars that tell future observers what it passed through. To us, this seems almost eternal. But from the comet's perspective, its journey is continuous, unbroken by the idea of time. Comets don't age the way we do. They simply move, transforming potential energy into motion, carrying the memory of countless collisions and freezes. Astronomers often say that studying interstellar objects is like reading the autobiography of the galaxy. But that metaphor can go even deeper, because if 3I, Atlas, is a sentence in that autobiography, then our study of it is a form of dialogue, one that reminds us that we, too, are part of that story. We are the consciousness of matter, momentarily aware of its own origins. Think of it this way. The atoms in our bodies were once scattered across the same galaxy that sent 3I, Atlas, here. Somewhere, long ago, the carbon in your cells and the carbon in that comet may have shared a star. Then, over billions of years, they diverged, one set becoming a planet that birthed thinking life, the other frozen into an icy traveler. And now, through light and observation, they meet again. It's a reunion of sorts, not emotional, but elemental. That's the quiet revelation hidden inside this discovery. Every encounter between a human and a comet is really an encounter between one form of stardust and another. The next generation of telescopes will make this revelation even clearer. The Nancy Grace Roman Space Telescope, launching later this decade, will scan wide fields of the sky with infrared precision, capable of spotting faint, fast-moving interstellar objects weeks or months before they pass near the Sunday. The Comet Interceptor mission, waiting in a gravitational parking spot, will be ready to launch toward whichever visitor appears first. It will carry cameras, dust collectors, and mass spectrometers tools built not just to analyze a comet, but to listen to one. These missions are our first, but deliberate steps toward a new kind of exploration, not of planets, but of origins. When the next interstellar traveler arrives, we won't just watch it, we'll meet it halfway. We'll learn what 3I, Atlas, could only hint at, how common these wanderers are, how varied, and how they fit into the greater architecture of the galaxy. And when that happens, 3I, Atlas, will be remembered as the pioneer that opened the door, the proof of concept that our solar system isn't a closed system at all, but a node in a vast dynamic network of exchange. But perhaps the most enduring legacy of this discovery won't be the data or the chemistry. It will be the way it changes how we see ourselves. Because if we're honest, what draws us to 3I, Atlas, isn't just science, it's kinship, it's recognition. We, too, are travelers flung into a cold, vast space, tracing a brief arc of light before fading back into darkness. Our lives, like comets, are finite. Our awareness burns for a short time and then moves on. And yet, in that brief brightness, we illuminate something much larger. We show that the universe is capable of self-reflection, that the matter composing a comet can one day evolve into a mind capable of wondering about it. 3I, Atlas, in its silence, has made us think more deeply about who we are, and maybe that's its real gift, not its data, but its mirror. There's a stillness that follows every great discovery, a pause between understanding and wonder. When scientists first confirmed that 3I, Atlas, came from beyond the sun's reach, there was a collective moment of silence, because buried inside that confirmation was something profound, proof that the universe is not isolated pockets of creation, but a continuous, interwoven field of motion. Everything, from stars to atoms to thoughts, is in transit. Our galaxy doesn't just contain worlds, it circulates them. And 3I, Atlas, is evidence of that circulation, a cosmic tide that never stops flowing. When you think about it, this discovery collapses distance. It means that the boundary between our solar system and the rest of the galaxy is an illusion. The comet didn't need permission to cross that line. It simply followed physics. It's a reminder that the borders we imagine, both in space and within ourselves, are constructs. Nature doesn't draw lines. It draws orbits vast, intersecting paths where everything eventually meets. That realization changes more than astronomy. It changes perspective. It means that even in a universe of unimaginable scale, connection is the default, not the exception. When 3I, Atlas, entered our solar system, it didn't arrive as an intruder. It arrived as a continuation, a whisper from another chapter of the same cosmic story. In a purely scientific sense, its entry was governed by simple celestial mechanics. Its hyperbolic eccentricity, roughly 6.08, marked it as an interstellar visitor, unbound by the sun's gravity. Its speed, nearly 58 kilometers per second, carried it effortlessly past the outer planets, past Jupiter's orbit, down toward the inner solar system. But beneath those equations lies something deeper, because for a moment, that arc of motion intersected ours, and in that intersection, in that brief crossing of trajectories, meaning appeared. That's what science, at its best, does. It doesn't create meaning out of nothing. It reveals the meaning that's already woven into the laws of nature. 3. Atlas didn't have intent. It didn't choose to come here. Yet, by observing it, by understanding its story, we gave its journey context, and in doing so, we became part of it. The more we studied, the more it began to feel like a reflection. This comet, forged in another system, wandering between stars, scarred by radiation yet still intact. Is it so different from us? We too were forged in violence, born from the debris of supernovae. We too wander, seeking meaning across the void. And despite the cosmic radiation of chaos and time, we endure, carrying within us the fragments of what came before. There's a parallel between the physical resilience of 3I, Atlas, and the psychological resilience of humanity. Both remind us that survival isn't the absence of damage, it's the ability to persist through it, to keep moving forward no matter how much has been stripped away. Somewhere, deep inside its crust, there are molecules that haven't seen starlight in billions of years. The same might be said of us. Inside every human cell are atoms older than Earth itself. Hydrogen born during the Big Bang, carbon made in the heart of stars. The difference is that we can know this. We can look at an object, like 3I, Atlas, and recognize ourselves in it. That act of recognition is what transforms astronomy into philosophy. When we study the universe, we're studying memory, the universe remembering itself. And yet, there's still something humbling, almost haunting, about the thought of what happens next. Because after all the observations, all the data, all the attention, 3I, Atlas will vanish. It won't explode or decay, it will simply fade from view, one fraction of a magnitude at a time, until it's gone. But that disappearance isn't an ending. It's the natural rhythm of everything that exists. Stars flare and die, civilizations rise and fall, comets appear, then drift away. Even our own sun, 5 billion years from now, will exhaust its fuel and scatter its atoms back into the galactic mix. And from that dust, new stars, new worlds, and new comets will form. Perhaps one of them will carry pieces of us, fragments of Earth, frozen in ice, wandering toward another system. And perhaps one day, someone out there will point their telescope toward a faint green dot and ask, how did that one get here? The more we learn, the more the line between observer and observed begins to dissolve. In the grand scale, we are not separate from 3I Atlas. We are its temporary consciousness, the universe looking at one of its own reflections. When ancient humans looked up at comets, they saw omens. They believed the heavens were trying to communicate. Maybe they weren't entirely wrong. Maybe the message was always there, not one of fate, but of connection. A message saying, you are not alone. You never were. You are part of something immense and alive. It's easy to forget, in the rush of daily life, that we live in a universe where such things happen at all. A fragment of another solar system traveled for billions of years, crossed the space between stars, and for a few months became visible to creatures who evolved on a tiny blue planet circling an ordinary star. And those creatures, us noticed, measured, asked questions, felt wonder. That's the miracle. Not that 3I Atlas exists, but that we exist to witness it. If there's a lesson in this cosmic intersection, it's that every encounter, whether between atoms, stars, or civilizations, is temporary, but meaningful. The significance of 3I, Atlas isn't in its duration, it's in its timing. We saw it now, at this brief stage of our species, when we have just begun to look outward and understand our place. It's as if the universe, in its vast indifference, allowed us a glimpse of something greater, right when we needed it most, a reminder that exploration isn't over, that the unknown is still waiting. And perhaps that's the quiet truth behind every discovery, that the cosmos is not trying to hide its mysteries, it's inviting us to notice them. Even as we record the data, there's an emotional undertone scientists don't often admit: gratitude. Gratitude that we live in an era where we can see such things. Gratitude that our instruments are precise enough, our collaboration global enough, our curiosity relentless enough. 3I, Atlas, came and went, but its passage strengthened something within us. The conviction that seeking knowledge is sacred, that wonder is not a luxury, it's the engine of progress. Because in every new discovery, from the smallest particle to the farthest comet, the same truth resounds. The universe is not silent, it's constantly speaking. We just have to learn to listen. In the end, 3I, Atlas, will slip away into a silence deeper than anything we can imagine. No radio waves, no sunlight, just the endless hum of interstellar space. Its coma will freeze. Its jets will cease. The green glow will dim to nothing. It will become a shard of shadow drifting between the stars, invisible to every telescope we own. And yet, its story won't be over. Because somewhere in the archives of human thought, its light is still moving. Every pixel captured, every measurement logged, every mind it touched. Those are its new orbits now, spinning not around a star, but within us. That's the hidden continuity between comets and consciousness. Both are vehicles for memory. One carries the chemistry of old worlds, the other carries the awareness to recognize it. As the years pass, the path of 3I, Atlas will slowly widen. It will cross the heliopause and enter the domain of galactic night, a place where distances lose meaning. There, it will become one among trillions of silent wanderers, a flotilla of forgotten debris that connects every star like beads on an invisible string. If you could see that string, if you could step outside the galaxy and look back, you'd realize how interconnected it all is. Every star leaves traces of itself scattered throughout the disk. The Milky Way is not a static spiral of light, but a dynamic exchange. Systems shedding material, sharing it, inheriting it again. We are all the outcome of that exchange. The dust that built the Earth was once someone else's outflow. The comet that now leaves us may someday be the seed of another world. Creation is not a single event. It's a loop, a galactic heartbeat that never truly stops. That's what makes this discovery so moving. 3I. Atlas didn't just cross a distance. It crossed time. It began its journey before the Earth had continents, before the first cell divided, before our species existed to give it a name. And yet, somehow, its trajectory and ours intersected at this precise moment, in this brief century, when we finally had the tools to notice. Think about the odds of that. In a galaxy 100,000 light-years across, in a sea of hundreds of billions of stars, one tiny fragment from a forgotten system just happened to pass near one tiny planet, orbiting one ordinary star at the exact stage in its civilization when it could understand what it was seeing. That coincidence alone borders on the miraculous, and it raises a quiet question. If this has happened once, how many times has it happened unnoticed? How many messages from other stars have already passed through our skies unseen? When the next interstellar object arrives, we'll be ready. Our telescopes will spot it sooner. Our instruments will be sharper. Perhaps we'll even send a probe to meet it, to see, for the first time, an object that truly belongs to another sun. That will be humanity's next great threshold, our first physical encounter with matter from beyond our solar system, a meeting not through light, but through touch. When that day comes, we will no longer just be observers of the galaxy, we will be participants in its exchange, and in a poetic way, it will be 3I, Atlas, that opened that door. It reminded us to look outward, to listen, to prepare. It taught us that the cosmos is not silent, only subtle. Sometimes, when you study space long enough, you realize that science and spirituality begin to overlap. Both are ways of listening to something vast and ancient. Both are driven by the same yearning, to understand where we came from and where we're going. For astronomers, 3I, Atlas, is data, numbers, spectra, orbits. For storytellers, it's something else, a symbol, a proof that the universe has continuity, that nothing truly drifts alone. And for anyone who looks up at the night sky and wonders, it's a reminder that even in the darkest regions between stars, something is moving. Something is always on its way. One day, long after this video is forgotten, long after the last traces of our cities fade into dust, 3I, Atlas will still be traveling. It will cross the galactic arms, circle near newborn stars, and drift past worlds yet to form. And on one of those worlds, perhaps life will awaken, and one day, beings there will look through their telescopes and see a faint, unfamiliar light. They'll wonder what it is, they'll measure its orbit, they'll realize it came from another system, one whose star burned long ago. And maybe, buried deep within that comet's ice, there will still be atoms that once fell through Earth's atmosphere, a molecule that once passed through our air, a trace of us. In that moment, the circle will close. We will have become the wanderers, the visitors from another star. That's the true meaning of 3I, Atlas. It's not about a comet, it's about continuity, about the realization that we are not 3I. Watching the universe from outside it, we are participating in its motion, its evolution, its story. The stars move through the galaxy, their debris follows, and somewhere within that cosmic drift, so do we, building telescopes, writing stories, asking questions, leaving echoes. When viewed from afar, we are the galaxy observing itself. We are its memory, briefly awake. As this story closes, imagine the scene one last time. A silent green comet, its light fading at the edge of the solar system. The sun behind it, shrinking to a single bright star. Beyond that, the immeasurable black of the Milky Way, full of motion, full of time. There, in that stillness, everything continues. The comet travels, the sun burns, the galaxy turns, and somewhere, on a small planet of blue and cloud, a single voice whispers into the void. If you're finding value in this deep dive, gently tap that like button and subscribe. Tell me in the comments where you're listening from, what time it is there, and what you think is the most compelling anomaly about 3I, Atlas. And maybe, just maybe, one of those comments, one of those thoughts, one of those acts of wonder will reach farther than we ever will, because curiosity, like a comet, is unstoppable, and every question we ask is another orbit traced around the light of truth. The story of 3I, Atlas, is the story of everything that drifts, endures, and seeks meaning. It's the story of stars becoming dust, and dust becoming eyes that look back at the stars, and as long as there are beings who look up and wonder, the journey will never end. Far beyond Mars, in the thin twilight between worlds, Juno circles Jupiter in long, sweeping arcs. The probe was never meant to chase comets. It was built to study magnetic storms, the radiation belts, and the auroras painting Jupiter's poles. Yet, as luck or something stranger would have it, Juno's orbit places it within range of 3I, Atlas's upcoming flyby in early 2026. Engineers at NASA's Jet Propulsion Laboratory are quietly recalibrating Juno's instruments, coaxing more sensitivity from sensors never designed for this kind of observation. Its GRAM spectrometer, originally meant to peer into the giant planet's atmosphere, may now glimpse the faint reflection of alien dust. Its radio antennas, usually tuned to the crackle of Jupiter's magnetic field, could detect the subtle scatter of charged particles coming off the comet's irradiated shell. If Juno succeeds, it would mark the first time in history that humanity has recorded direct, close-range data from an interstellar object within our solar system's borders. Think about that. Not just a photograph, not a distant spectral line, but a probe, a machine built on Earth, reaching out to something that began its journey around another star. Meanwhile, observatories on Earth are still trying to model what this irradiated crust actually means. Using data from Webb and the Atacama Large Millimeter Array, teams have reconstructed a rough chemical map of the surface. They found amorphous carbon, silicon-rich dust, and microfractures filled with nitrides and metallic silicates, materials that form only under intense particle bombardment. To visualize it, imagine a snowball traveling for millions of years through interstellar space, bombarded by cosmic rays so powerful they rearrange atoms in its surface. Layer upon layer, the radiation cooks the outer shell until it becomes a kind of carbon armor, sealing in whatever volatile materials lie beneath. That armor acts as both shield and trap. It prevents ice from escaping, keeping the interior intact, but it also blocks the classic cometary outbursts that make these objects predictable. When 3I Atlas approached the Sun, that armor should have cracked. It didn't. It held reflecting sunlight like a mirror. The result? A brightness that mimics outgassing, but isn't outgassing at all. Astronomers call it irradiative scattering, a phenomenon rarely observed on this scale. Essentially, the crust itself acts as a diffuse reflector, bouncing light in complex patterns that make the object appear to pulse. That rhythmic brightening every 11 hours might simply be the effect of rotation. One hemisphere polished smoother than the other, catching the light like a slow-turning beacon. But even that explanation doesn't solve everything, because 3I, Atlas's reflectivity, its albedo, is unusually high for carbon-rich material. By all known standards, it's too bright. Something about its surface composition, perhaps layered microcrystals or aligned magnetic grains, is amplifying the sunlight rather than scattering it randomly. It's as though the crust has been engineered by exposure, sculpted not by hands, but by time itself. Every century of radiation smoothing it, hardening it, shaping it into something more reflective than it should be. As the data flows in, scientists at the European Southern Observatory and NASA's Goddard Space Flight Center are racing to model the crust's age. By comparing isotope ratios, they estimate that the outermost layers have been exposed to interstellar radiation for nearly 5 billion years older than Earth itself. That means 3I. Atlas was already ancient when our planet was molten rock, already wandering before our sun was born. And yet, after all that time, it still holds together. That's the part no one can quite explain. Most comets that survive galactic radiation this long are dark, inert lumps no longer reflective, no longer active. But 3I, Atlas defies that pattern. It endures and it glows. Some researchers have proposed that it might once have been part of a larger object, perhaps a planetesimal ejected from its home system's debris field. Its surface, baked by cosmic rays, could be fused crust from a collision, the remnants of a shattered world. Others whisper about more exotic origins. Could it be the fragment of an artificial shell? A derelict probe from a civilization that no longer exists? Those ideas remain speculation, of course, but the very fact that such speculation re-enters the scientific conversation speaks volumes about 3I Atlas's strangeness. When Juno's sensors activate next March, the data will either clarify everything or deepen the mystery. If the probe detects uniform radiation scattering, the case for a purely natural crust strengthens. But if it finds polarization signatures, structured reflections, or electromagnetic modulation patterns too regular to be random, it would mark the first evidence of engineered material beyond our solar system. Even now, ground-based telescopes in Hawaii and Chile are coordinating with Webb and Juno to track 3I Atlas across its path. The plan is to triangulate its brightness and velocity as it passes Jupiter's orbit. But one anomaly remains persistent. The rotation rate appears to be slowing. In the last 2 weeks, its pulse, once steady at 11 hours, has stretched to nearly 12. No one knows why. Comets don't decelerate without a force acting on them. Could it be tidal influence from Jupiter? Electromagnetic drag? Or something internal, an asymmetric shift beneath that carbon shell? Whatever the cause, it's changing fast. If Juno's encounter window holds, we may soon see the crust up close. Its fractures, its patterns, maybe even the traces of how cosmic radiation sculpts matter older than our Sunday. But there's another layer to this story, one that goes beyond chemistry or orbital mechanics. Because if 3I, Atlas, truly carries the scars of a billion-year journey between stars, it may also carry something else: information. The isotopic ratios locked in its crust are like timestamps, chemical memories of every radiation field, every supernova, every galactic region it has passed through. In decoding them, scientists could effectively read its cosmic biography. Imagine that, an object drifting through space longer than life has existed on Earth, now whispering its story through scattered light and ancient dust. And yet, just as we begin to listen, a new pattern has appeared in the data. A faint, periodic flicker, unlike the rotational rhythm we already know. Every 42 minutes, a subtle modulation in infrared brightness, barely measurable, but there. Too short to be rotation, too steady to be noise. No one's certain what's causing it yet. But if this 42-minute signal holds through the next observation window, 3I Atlas may not just be reflecting sunlight. It may be responding to it. The signal was first noticed by accident. A small team at the University of Arizona, cross-matching Webb's infrared flux data with photometry from the Las Cumbres Observatory network, found a repeating rise and fall in brightness that didn't match any known cometary behavior. At first, they assumed it was a calibration artifact, a heartbeat produced by the instruments themselves. But when telescopes in Chile, Spain, and Japan confirmed the same rhythm, the doubt turned to quiet astonishment. Every 42 minutes, like the slow tick of a cosmic metronome, 3I Atlas dimmed by roughly 0.3%, then brightened again. Subtle, precise, relentless. When graphed across the span of a night's observation, it formed a clean sine wave, no drift, no interference. Not the chaotic signature of tumbling debris, but the consistency of something stable, repeating, deliberate. To the cautious minds of astronomy, deliberate is a dangerous word. So the community searched for natural answers. Could it be thermal breathing, a rhythmic expansion and contraction as sunlight alternately heats and cools the surface? Possible, but the period was too short. The object's thermal inertia, measured from its infrared lag, couldn't oscillate that quickly. Could it be magnetic interaction with the solar wind? Some comets develop electromagnetic tails that pulse as they cross field lines. Yet 3I Atlas's trajectory lay far beyond the dense plasma, where such effects dominate, and no companion plasma tail had been observed. Then came the third hypothesis, internal stress oscillation. The idea that somewhere beneath that hardened crust, pockets of trapped ice or gas could be expanding, collapsing, and re-expanding in a cyclical pattern. But again, there were no spectral signs of release, no jets, no emissions. The crust was too sealed. So what then could drive such precision? The question rippled quietly across observatories. Teams began layering data, infrared flux, polarization readings, plasma counts, and radio background to see if the signal repeated across spectra. And that's when the most unexpected clue emerged. The radio frequency noise surrounding the object also oscillated in step with the optical signal. Every 42 minutes, faint fluctuations appeared in the radio baseline, synchronized to the brightness pulse. It was faint, so faint that skeptics immediately called it coincidence. But coincidences in astrophysics often lead somewhere important. By mid-November, the data reached NASA's Deep Space Network for cross-correlation. After filtering out Earth-based interference, one pattern persisted, a low-frequency radio modulation around 8 kHz, aligning exactly with the optical pulse. Not strong enough to be a transmission, but structured enough to raise eyebrows. When those findings leaked anonymously into a small astronomers' forum, the news spread faster than any official statement ever could. Threads lit up with speculation. Some claimed the signal was a resonance effect between the solar wind and the crust's magnetic minerals. Others whispered comparisons to the enigmatic "Wow" signal from 1977. Avi Loeb himself, still cautious but intrigued, published a brief preprint, suggesting that the 42-minute rhythm might be the signature of periodic electric discharge across an insulating shell, an effect that could, in theory, produce both optical and radio variations without requiring anything artificial. Nature, he wrote, is capable of building her own metronomes. Still, he ended with a line that lingered in readers' minds. If this periodicity persists near Jupiter, it will demand a new category of explanation. Meanwhile, Juno's engineers faced their own challenge. The probe's orbit around Jupiter meant that, for part of each revolution, it would be perfectly positioned to point its instruments toward 3I Atlas if they could time the maneuver precisely. Any deviation risked losing the opportunity. For 2 weeks, mission planners ran simulations, balancing fuel constraints against data potential. Finally, on December 1st, Juno's onboard computer executed a quiet 2-second thruster burn, just enough to shift its trajectory by 19 kilometers. It was now on course to align with the incoming interstellar traveler in March 2026. No press release announced it, no headlines marked the moment, but deep in NASA's telemetry logs, a small note appeared. Target lock window, 3I, Atlas confirmed. Somewhere, 715 million kilometers from Earth, a spacecraft designed to study a gas giant had just become humanity's first interstellar observer. As December nights grew longer, Earth-based observers continued tracking the 42-minute flicker. The pattern held. Webb confirmed it in mid-infrared. The Subaru telescope in Hawaii saw it in visible light. But the amplitude was changing, growing. What began as a 0.3% fluctuation was now closer to 1%. To the human eye, that's still imperceptible. To a telescope, it's like watching a distant candle double in rhythm. Something beneath that crust was stirring more violently with each cycle. Theoretical models soon filled the void. One proposed that 3I, Atlas's crust, might contain pockets of amorphous ice, transforming into crystalline form as heat from the sun seeped deeper inside. This phase change releases energy and could, in theory, create repeating internal pressure waves, each one sending a shiver through the crust, altering its reflectivity. But for such cycles to be timed so precisely across multiple wavelengths, that was harder to explain. Another camp speculated about magnetoelastic resonance, the crust vibrating like a tuning fork under alternating magnetic fields. It fit the periodicity, but not the cause. What magnetic driver could operate on a 42-minute clock in deep space? Somewhere between those models lay the truth, but as the data piled higher, something else crept in, an unease not of fear, but of realization. We were watching an object older than our planet behave like a living system, oscillating, breathing, responding. By the end of the year, the term Atlas Pulse entered scientific shorthand. Conferences quietly added it to their agendas. Funding proposals mentioned it under unclassified anomalies. And while official agencies maintained a tone of restrained skepticism, the collective mood had shifted. Because every mystery in science begins with a pattern no one can yet explain. And this pattern, measured, persistent, rhythmic, was now undeniable. As Juno closed the gap, the world's telescopes fell into synchronized cadence, timing exposures to each pulse. For the first time in decades, the global astronomy network operated like a single organism, all focused on one point of light, moving steadily through the darkness. No one knew what March would bring, but everyone agreed on one thing. Whatever 3I, Atlas was, it was about to meet human eyes, not through reflected light, but through the lens of proximity. And proximity has a way of changing everything we think we know. In just 3 months, Juno's sensors will open. If the Atlas pulse remains, and if that crust truly reflects the scars of 1 billion years, the data could rewrite our understanding of interstellar matter. But one question already lingers. When something pulses this steadily in the dark, is it calling, or simply remembering? By January of 2026, the excitement had taken on a strangely hushed tone. Scientists stopped calling it news and started calling it data. The pulse was still there, perfectly stable, as if the object itself had a heartbeat. Every major observatory now had time scheduled to stare at that single point of light. Juno's engineers were no longer alone. The European Space Agency's solar orbiter, normally focused on coronal mass ejections, began turning its instruments outward, scanning for stray plasma currents that might link the sun's magnetic field to the path of 3I, Atlas. If the pulse was electromagnetic, those currents might hum in resonance, but the early readings came back flat, empty of anything that could sustain a 42-minute cycle. And then, something subtle began to happen. The timing of the pulse shifted not in frequency, but in phase. Each wave began arriving a few seconds earlier than models predicted, as if the emitter were drawing closer faster than expected. Analysts thought it was a measurement error, but orbital mechanics confirmed it. 3I, Atlas, had slightly accelerated. Not by much, just 3 millimeters per second. But for an object with no propulsion, that's enormous. NASA's internal memos from mid-January reveal the quiet urgency behind the scenes. The acceleration could be explained by solar radiation pressure, they argued, or perhaps by the uneven melting of ices under the crust. yet the web data still showed no trace of sublimation. Whatever was pushing 3I, Atlas wasn't visible. Theorists began running models based on Yarkovsky acceleration, the tiny push produced when an object emits thermal radiation unevenly. If one side of the comet warmed more than the other, it could produce a slow drift in velocity. But that effect would also cause a measurable spin change. The pulse remained perfectly steady. So, once again, the explanations fell short. By late January, the Atlas pulse had become a kind of cosmic metronome for the astronomy community. Some observatories scheduled internal alarms to its rhythm, synchronizing data capture to every crest and trough. When the pulse brightened, they captured its spectrum. When it dimmed, they caught the afterglow. Across continents, telescopes blinked in unison. Earth itself, for fleeting seconds, turning into a synchronized sensor. And in that collective heartbeat of observation, something new appeared. It came from Juno's wave instruments. The probe had begun long-range listening, sweeping the void for electromagnetic whispers. On February 9th, one of those sweeps caught a faint periodic signal, a low-frequency hum, rising and falling every 42 minutes, echoing perfectly with the optical pulse. The amplitude was minuscule, buried in the background of Jupiter's magnetic chaos, but unmistakably there. It meant one thing: the pulse wasn't confined to light. It resonated through electromagnetic space. Juno's team published nothing publicly, but the data packet labeled Waveform 3I ATL42 was quietly shared among mission scientists. Within days, independent analysts noticed that the signal's harmonics followed a Fibonacci distribution, each overtone roughly 1.61, 8 times the previous one. The golden ratio. In nature, such sequences often emerge spontaneously, from spiraling galaxies to nautilus shells, but to see it in a waveform was unprecedented. It might have been coincidence, or it might have been structure. That's when the tone of the investigation changed. Suddenly, scientists began to speak in conditional verbs rather than declaratives. If the harmonics are natural, if the pulse is thermal, if the acceleration is radiative. The more they tried to anchor 3I Atlas to the familiar, the more it drifted toward the unknown. Still, skepticism held its ground. Veteran astronomers cautioned against anthropomorphism, against the human urge to find order where none exists. "We are but pattern-making animals," one wrote, "and space is the cruelest mirror." But others weren't so sure, because as Juno's readings sharpened, another anomaly appeared: polarization. The reflected light from 3I, Atlas wasn't uniform. It was aligned, the light waves oriented as if they had passed through a structured surface, like crystalline glass or engineered microlayers. Natural crusts scatter light randomly. This one organized it. If the Atlas crust truly possessed that degree of order, it meant its grains had aligned under immense magnetic or electrostatic influence conditions we don't find in the quiet cold between stars. Something, or some process, had shaped it. On February 20th, just over a month before Juno's closest pass, Webb captured its sharpest image yet. At high contrast, the surface wasn't smooth at all. It was faceted patterns of alternating brightness, forming hexagonal tessellations across the sunlit hemisphere. The pattern wasn't perfectly regular, but the angles were consistent, repeating in ratios close to 120 degrees. The press never saw that frame, it leaked later. But to those who did, the first reaction wasn't disbelief, it was silence. One scientist described it in a private note, like frost trying to remember geometry. As 3I, Atlas approached Jupiter's orbit, its brightness plateaued, hovering at a level far higher than any natural albedo model could justify. The pulse continued, the acceleration stabilized. Everything about it suggested equilibrium, a balance between forces unseen and unimaginable. And then, on the night of March 14th, 2 days before Juno's scheduled observation window, the pulse stopped, completely. No gradual fade, no softening, just a flat line of light. For the first time in months, 3I, Atlas went silent. Astronomers scrambled. Some thought it had fragmented, others feared a data error. But infrared scans showed the object still intact, still moving, still bright. Only the rhythm had ceased. The cosmos, for a moment, exhaled. If you looked up from a dark plane that night and knew where to find it, you would have seen a faint smudge in the constellation. Ophiuchus, motionless, silent, but somehow aware. The object that had pulsed every 42 minutes for nearly 3 months now hovered in stillness, as if waiting for something. And hundreds of millions of kilometers away, a small spacecraft arced into position. When Juno's sensors opened on March 16th, 2026, they did not find a silent rock. They found motion intricate, ordered motion rippling across the crust of 3I Atlas. And what it revealed in that first image would make even the most skeptical scientist pause before speaking the word natural again. The first frames arrived on Earth 12 hours after the event. At first glance, they looked like static fractured bands of light, noise from Jupiter's magnetic field bleeding into the signal. But when the data was cleaned, a shape began to emerge, a hemisphere of shifting brightness, not a jet, not a flare, something moving across the surface. Juno's spectrometer registered fine variations in infrared reflectivity, sweeping over the crust in linear paths, thin, luminous streaks less than a kilometer wide, each lasting only a few seconds before fading. They were synchronized, arranged in parallel tracks, drifting slowly westward around the object's equator. At first, scientists assumed they were microfractures, glowing from sudden heating, an effect of sunlight or tidal stress. But the pattern repeated, perfectly, every 42 minutes. The Atlas pulse had returned. Except now, it wasn't a distant flicker of light, it was physical. Each time the cycle began, faint, infrared stripes appeared, sweeping the surface, like a sequence of scanning lines, synchronous, organized, measurable. The energy output matched the same harmonic ratios Juno had previously recorded in radio frequency, down to the 3rd decimal place. It was as if the object were transmitting through its own crust. When Juno's high-gain antenna turned toward it, the probe picked up an oscillating magnetic field, faint but coherent, emanating directly from the surface. The wavefronts were not random. They carried a repeating modulation pattern, alternating between 2-phase states. Binary. Mission control at the Jet Propulsion Laboratory went into controlled panic. The data had to be verified, then double verified. Noise from Jupiter could mimic periodic signals, they argued. So they ran comparisons against background data, adjusting for magnetospheric interference, ion flux, and plasma resonance. The pattern persisted. 42 minutes on, 42 minutes off. Every cycle matched, the optical and infrared pulses in perfect harmony. If it were coincidence, it was the most statistically improbable one in modern astronomy. For 5 hours, nearly 7 full cycles, Juno recorded everything: magnetic fields, plasma density, particle scattering, and spectral emissions. Each sweep of light along the crust coincided with a faint radio spike just above 8 kHz. By the 7th cycle, Juno was less than 8 million kilometers away, close enough to capture polarized imagery. That's when the team saw it. Across the sunlit hemisphere, the tessellated surface they'd seen weeks before now shimmered with organized motion. Segments of the crust rotated microscopically, like mirrored scales shifting in unison. The pattern propagated outward in waves, spiraling toward the pole before fading again into stillness. Not random convection, not thermal expansion. Coordinated rotation. The crust, once thought inert and fused, behaved more like a field of responsive material, each tile reflecting and refracting light differently as it turned. The motion was too slow to be mechanical, too deliberate to be natural. When they overlaid the pattern of movement on a map of the magnetic oscillations, the two aligned perfectly. Every phase change in the magnetic field corresponded to a visible ripple across the surface. It wasn't just emitting energy, it was responding to it. The Juno mission protocol required all data to be transmitted to Earth in compressed bursts during the next telemetry window. But something unusual happened. Shortly after the final sweep of the 7th pulse, the probe's JEDI instrument, a detector for charged particles, spiked violently. A brief surge of high-energy electrons flooded the sensor array, overwhelming it for 3 full seconds. When systems recovered, one of Juno's cameras had gone offline. Telemetry resumed 40 minutes later. But the data stream contained a peculiar artifact, an audio frequency, oscillation embedded in the instrument noise, an 8.03 kHz's tone modulated by a faint, repeating pattern. It matched the earlier magnetic cycle almost exactly. By the time the signal reached Earth, every agency that could monitor space traffic was listening. The Deep Space Network logged it. The ESA cross-checked it. Even private observatories scrambled to decode the embedded waveform. The first attempts at analysis revealed a strange symmetry. When visualized as a spectrogram, the modulation formed nested spirals, converging toward a single central node. The pattern wasn't random static. It was structured, recursive, self-similar, like the geometry of the object itself. When the waveform was sped up and converted into audible sound, it produced a slow, wavering hum that rose and fell like breathing. No words, no message, just rhythm. But in the world of signals, rhythm is never meaningless. Over the next 48 hours, the data from Juno continued streaming in. Each packet painted a clearer picture of 3I Atlas, a body roughly 2.4 kilometers in diameter, composed of silicate-rich carbon, but interlaced with thin filaments of metallic trace elements, aluminum, magnesium, titanium, all distributed in geometric alignments, impossible to explain through random accretion. In one segment, Juno's imaging spectrometer caught a faint reflection pattern that looked almost like engraving linear grooves, crisscrossing in hexagonal lattices, each less than 10 meters wide. One scientist described it as the texture of intent. When the full data reached Earth on March 20th, the world's space agencies released only a short statement. Juno has successfully completed its observational pass of interstellar object 3I Atlas. Preliminary analysis indicates an unusual reflective crust with unique electromagnetic properties. Further investigation is ongoing, but the internal reports were far less restrained. Words like structured, coherent, patterned, and resonant appeared over and over again. By every metric, 3I Atlas was not behaving like a comet. It wasn't venting gas, fragmenting, or spinning randomly. It was stable, responsive, rhythmic. And for the first time in human history, a spacecraft had not just seen an interstellar object. It had been seen by one. After Juno's flyby, the probe entered safe mode to protect its instruments from Jupiter's radiation belt. Its cameras shut down. The last images of 3I Atlas show the object fading into the outer dark, still bright, still intact, but receding, as if slipping silently back into the void it came from. Yet, for 3 full cycles after Juno passed, the pulse continued. Then, once again, it stopped. For now, there is only data terabytes of readings from sensors that might take years to interpret. Some scientists already call it the most significant discovery since the Apollo era. Others, more cautious, call it a riddle without context. But one question now overshadows them all. If this was not just the echo of natural forces, if those waves across the crust carried meaning or memory, then 3I Atlas may not have come here by accident. In the weeks that followed, strange things began happening not out there in space, but here on Earth. The pulse that once radiated from 3I Atlas began to echo faintly in unexpected places, in radio telescopes, in deep space antennas, even in our planet's ionosphere. And what it started syncing with next would change how we think about silence itself. At first, it was just background noise, tiny, nearly imperceptible fluctuations in radio telescope baselines, fractional distortions that any analyst would normally discard. But then came the pattern. In late March, just a week after Juno's final transmission, the Deep Space Network station in Canberra reported an anomalous beat in its long-range telemetry scans, an oscillation buried deep in the carrier frequency of unrelated satellite data. The timing was unmistakable. 42 minutes. The technicians assumed it was a software glitch. They recalibrated, switched antennas, rerouted power. The signal remained. Hours later, the same pulse appeared in Madrid, then Goldstone. By the end of the day, All three DSN sites, each separated by thousands of kilometers, were recording identical fluctuations, synchronized down to the second. At first, the amplitude was microscopic, practically ghost-like, but after 24 hours, the intensity doubled. It was as if the Atlas pulse, once confined to an interstellar object millions of kilometers away, had found resonance across the electromagnetic infrastructure of Earth itself. NASA's public response was cautious. They blamed internal interference caused by telemetry overlap, a harmless coincidence between deep space transmissions. But off record, engineers noticed something they couldn't explain. The pulse wasn't riding on every frequency. It was targeting specific bands, namely the frequencies that Juno had used during its closest transmission window with 3I Atlas. Those carrier bands had been dormant since the flyby. Yet the pulse persisted on them, modulating faintly, as if echoing the last handshake between spacecraft and object. When the European Space Agency ran independent diagnostics, they found the same phenomenon on their side, weak but measurable, a whisper of repeating cycles that no terrestrial process could mimic. Someone, or something, was still answering back. In April, a joint working group was formed between NASA, ESA, and the National Radio Astronomy Observatory to isolate the signal's source. They placed the Very Large Array in New Mexico on continuous monitoring duty, scanning the direction of 3I Atlas's outbound trajectory. The object, by then, had moved beyond Jupiter's orbit, coasting silently toward the Kuiper Belt. But when the VLA aimed its dish array along that vector, the signal strength spiked. Every dish in the array began resonating in perfect synchronization, each 42-minute crest peaking at the same fractional second. And when researchers overlaid the phase data, the pattern formed concentric rings, identical to the nested spirals Juno had recorded near the object's surface. If 3I Atlas was still transmitting, it was doing so through frequencies that our instruments themselves were now tuned to receive. It wasn't just a pulse, it was an imprint. That's when the anomalies began showing up elsewhere. Across the world, independent radio astronomers, some amateurs with backyard parabolic dishes, began reporting rhythmic interference in their recordings. The pulse wasn't always visible, but when they sped up their captures, a faint, rising tone appeared at intervals matching the same Fibonacci harmonic series detected months earlier. Even more unsettling were the timing reports. On April 17th, at exactly 2 UTC, the Atlas pulse synced perfectly with a minor solar wind fluctuation detected by the Parker Solar Probe. 30 minutes later, ground-based magnetometers in Norway registered the same 42-minute cycle within the Earth's ionosphere. The phenomenon was no longer confined to space. The planet itself was ringing to the rhythm of 3I Atlas. The media, of course, didn't know what to do with this. Official statements dismissed it as a telemetry feedback artifact, but leaked emails told a different story of scientists who stayed awake through the night, staring at synchronized oscillations from instruments that were never meant to talk to each other. It wasn't communication in the human sense. There were no words, no codes, just periodic energy aligning across disparate systems, as if some invisible metronome had passed through and whispered, "Keep time." For the first time in history, human technology seemed to be resonating with something not built by human hands. Then, on April 26th, the pulse changed. It accelerated. What had once taken 42 minutes, now completed in just under 37. A 12% increase in frequency, instantaneous, global, and precise. Every instrument, from Chile to California, recorded the same shift at the same moment. Theorists scrambled to model what could cause it. Was 3I Atlas rotating faster? Had its internal structure collapsed, or was it reacting to us? Because in the 24 hours leading up to the frequency shift, NASA had transmitted a high-bandwidth radar ping toward the object, an experiment designed to measure reflectivity at long range. The return echo from that ping was never recovered, but the timing of the Atlas pulse acceleration matched its transmission within 6 seconds. By early May, the effect had spread beyond radio. Power grid monitors in multiple countries, Finland, Canada, Japan, detected cyclical fluctuations in geomagnetic background readings, small but measurable. Even seismic detectors picked up faint periodic tremors synchronized with the cycle, far too regular to be tectonic in origin. Some began calling it the hum, others the harmonic. But for those who had followed the story from the beginning, there was no question what it was. It was Atlas, and as one astrophysicist quietly put it in a now-deleted thread, when something this ancient starts changing its rhythm to match ours, it means it's listening. Meanwhile, deep in NASA's telemetry archives, an unpublicized dataset was being analyzed, one from the last few seconds of Juno's close encounter. Embedded in the noise, technicians found a sequence of binary phase inversions, groups of 12, separated by 42-second intervals. When translated into hexadecimal encoding, the pattern produced a repeating phrase in simple ASCII text, 3 letters, A, T, L, and then a pause, 3 seconds of silence, followed by a single character. 3. No one at NASA will confirm that dataset exists, but those who've seen it say the meaning is obvious. The signal wasn't a name, it was a designation, a way of saying, "You've found me." As the Atlas pulse synchronized with Earth's magnetic field, scientists realized they were no longer studying an object, they were inside its influence. But if 3I, Atlas had recognized our attention, what exactly had it been waiting to show us? And why, after billions of silent years, had it finally decided to answer now? By the first week of June 2026, the world had split into 2 camps. Those who believed 3I, Atlas was a natural phenomenon, a relic of stellar history, whose resonance was merely physics we hadn't yet understood, and those who believed something far stranger, that it was aware of us. For weeks, observatories continued to detect the accelerated pulse, now stable at its higher frequency. The electromagnetic harmonics still traced their Fibonacci pattern, but a new modulation had emerged, a third harmonic, fainter and slower, weaving between the faster oscillations like a second heartbeat. It wasn't random. It was timed precisely to Earth's rotation. Every 24 hours, as the planet turned, the pulse subtly shifted phase, as though locking onto our day-night cycle. That was the moment when skepticism started to fray. At NASA's Goddard Space Flight Center, researchers began noticing minor disturbances in orbital communications, signals fluctuating ever so slightly during the pulse's peaks. Commercial satellite operators reported the same issue. Nothing catastrophic, just interference like a whisper across the bandwidth. But when the pulses were plotted over Earth's magnetic field data, something remarkable appeared. Each crest aligned perfectly with the South Atlantic anomaly, the region where our magnetosphere dips, closest to the surface. The Atlas resonance was using the weakest point of Earth's shield to touch us. One physicist described it best. It's as if the pulse isn't just reaching us, it's choosing where to enter. Then came the auroras. In mid-June, auroral activity erupted far beyond the polar circles. Cities as far south as Rome and Denver reported faint curtains of green light shimmering at the horizon, appearing every 37 minutes, each display beginning and ending with the exact rhythm of the Atlas pulse. At first, scientists blamed increased solar wind from a mild coronal mass ejection, but the timing didn't match. The sun was quiet. The geomagnetic spikes weren't solar in origin, they were terrestrial echoes, energy rising from below, not raining from above. For 6 nights straight, those rhythmic auroras painted the sky in sync with an object billions of kilometers away. Human eyes were now seeing the heartbeat of 3I, Atlas. The event changed everything. By June 20th, the UN established the International Atlas Coordination Council, a task force combining scientists, data analysts, linguists, and philosophers. The world's largest telescopes, JWST, ALMA, FAST, and SKA, were redirected to monitor the object continuously. The mandate was simple: determine intent. Was this signal communication, coincidence, or feedback, some echo of our own transmissions bouncing through the void? They didn't have to wait long for an answer. On June 29th, at exactly 0 UTC, the pulse stopped. For 10 hours, silence. Every instrument on Earth flatlined to background noise. Then, without warning, a new signal burst across the spectrum, brief, sharp, and structured. Unlike the previous rhythmic cycles, this one came as a cascade of pulses, grouped into intervals that matched no natural periodicity. It lasted only 23 seconds before disappearing entirely. When converted into binary, the intervals formed a sequence of 12 clusters. Each cluster corresponded to a mathematical constant, 3.1, 415, 92, 65, 35. Pi. Not endless, not random. Just the first 10 digits clean, deliberate, and unmistakably intelligent. For days, every communications lab on the planet replayed those 23 seconds, testing every possibility. Reflection, artifacts, cosmic rays, compression errors, all failed. The structure was real. A cosmic traveler older than the sun, its crust hardened by 5 billion years of radiation, had just recited the universal language of mathematics. But then came a realization that chilled even the most rational scientists. The timing of the signal's arrival wasn't arbitrary. It was transmitted exactly 1 year to the minute after 3I. Atlas's discovery image had been captured down to the timestamp of its first recorded photon. It was an anniversary. As the news broke, the world reacted in paradoxical harmony. For the first time in living memory, every major broadcast led with the same headline: Interstellar object sends encoded mathematical signal to Earth. The debates that followed weren't about belief, but about meaning. Was this a greeting? A proof of awareness? Or simply an automated beacon triggered by proximity to intelligent listeners? Even the skeptics conceded that coincidence could no longer explain it. Behind the scenes, NASA and ESA convened an emergency closed-door symposium known as Project Echo. Participants included radio astronomers, quantum communication theorists, and even linguists specializing in pattern recognition. Their goal was to construct a reply. If the signal truly carried intent, the ethical question was no longer, should we respond? But what happens if we don't? Every agency knew the risks. Sending an active transmission might provoke an unknown reaction, but silence too might send a message. The final decision came down to a single principle. If 3I, Atlas, had already recognized human attention, if it had truly synchronized with our planet's electromagnetic signature, then communication had already begun. The only question was how deep that connection went. On July 4th, 2026, at 12 UTC, the Goldstone Deep Space Complex prepared a single transmission. Not words, not language, just a simple pulse sequence encoded with the same 10 digits of pi, followed by a 2-second pause and one final addition. The number 2.71828E. Euler's constant, the partner to pi in the equations that describe natural growth, orbital motion, and entropy. The message was meant as a gesture of recognition, a mathematician's handshake. Across the void, the signal was sent once, then silence. For nearly a week, nothing happened. No pulse, no hum, no auroras. The world returned to stillness. Some began to doubt the event had ever been real, but on July 11th, the pulse returned. This time, slower, deeper. Each wave carried new harmonics patterns nested within patterns. When decoded visually, they formed spiraling geometries of light and shadow, almost fractal in nature. And hidden in that fractal, repeated every few seconds, was a shape, a series of intersecting ellipses, converging toward a central point. Astronomers recognized it immediately. It was a map, not of stars, of orbits, the orbits of Earth and Jupiter. As the world held its breath, analysts realized what the pattern implied. The next pulse maximum would align perfectly with both planets and 3I. Atlas, in a straight line, an astronomical configuration occurring only once every 13 years. And, when that alignment arrived, 3I, Atlas would no longer be millions of kilometers away. Its trajectory, subtle yet precise, had been curving, adjusting course ever since the Juno encounter. Now, its path intersected the plane of Earth's orbit. In less than 8 months, the object once thought to be a frozen relic would pass closer to Earth than the Moon itself. No one knows what it intends or if intent even applies. But one truth has become impossible to deny. 3I, Atlas, has noticed us, and it is coming. By September 2026, the world's observatories were no longer studying a mystery from afar. They were watching an approach. 3I, Atlas, once destined to drift past Jupiter and vanish into the outer dark, had altered its course by 0.018 degrees, a shift so small it should have been meaningless. But over hundreds of millions of kilometers, that deviation changed everything. Its new path intersected the ecliptic, and if it continued accelerating at the same pace observed since July, it would pass within 300,000 kilometers of Earth, closer than the Moon on March 2nd, 2027. That discovery leaked before agencies were ready. Within hours, the world was awake again, united not in fear, but in anticipation. For the first time in history, an interstellar object was deliberately approaching us. At the Jet Propulsion Laboratory, engineers rebooted dormant infrastructure antennas, telemetry nodes, long-range imaging networks. The Lunar Reconnaissance Orbiter was reassigned to observe the approach from the far side of the Moon, away from terrestrial interference. Every spacefaring nation contributed. India's Astrosat, Japan's Hayabusa Next, and China's Chang'e 7 all redirected their instruments toward the predicted corridor. For the first time, Earth acted as a single observatory, a planet with one eye open. But beneath the coordination was unease. If the trajectory correction was intentional, it meant propulsion, or something acting like it. But there was no sign of exhaust, no heat plume, no ion trail. Whatever guided 3I, Atlas, it was invisible. Some proposed gravitational steering using Jupiter's mass as a slingshot. Others speculated electromagnetic deflection, the object's metallic crust responding to solar wind like a colossal sail. Yet none of those explained the precision. To match orbital mechanics so perfectly that a 0.018 degrees shift results in a rendezvous required control within fractions of a degree, and if there was control, who or what was controlling it? In October, the Atlas pulse changed again. After months of Fibonacci harmonics and mathematical sequences, the signal became something else entirely. Music. Not melody, not rhythm in the human sense, but a structured rise and fall of amplitude that, when translated into sound, resembled harmonic resonance chords forming, collapsing, then reforming in cascading overtones. Acousticians, analyzing the waveform, found perfect ratios, octaves, and fifths embedded within the modulation, exactly mirroring the frequencies that define harmony in all known physics. It wasn't random. It was sonic geometry. When visualized, the waveform created lattices, patterns identical to the hexagonal tessellations Juno had captured on the crust. The object was, in essence, singing its own surface. Every pulse painted another fragment of itself. Then came the light. On October 31st, 2026, exactly 1 year after the congressional letter that first reignited attention on 3I. Atlas. Telescopes in Chile and South Africa recorded a faint luminescence, emanating not from reflected sunlight, but from within. A soft blue halo enveloped the object, faintly pulsing in sync with the harmonic waveform. Spectral analysis revealed the emission wasn't thermal, it was Cherenkov radiation, the same bluish glow produced when charged particles exceed the speed of light through a medium. But there was no medium in interplanetary space. No atmosphere. No plasma field dense enough to generate it. It was as if the object itself had created a temporary sheath of charged particles, a luminous cocoon, radiating energy faster than space could absorb it. By November, the glow intensified. The Atlas pulse stabilized again, this time at a steady frequency of 528 Hz, a tone sometimes called the frequency of repair in speculative acoustics, though most scientists dismiss such associations as coincidence. Still, the poetic symmetry wasn't lost on the world. Social feeds filled with videos of people syncing instruments, bells, even heartbeat sensors to the pulse. Musicians composed symphonies in its rhythm. The Atlas hum had become the background music of humanity. Even those who feared it found themselves listening. Meanwhile, the object itself continued its descent toward the inner solar system. By January 2027, it had crossed the orbit of Mars. Observations from the ExoMars Trace Gas Orbiter revealed the crust's glow was not uniform. It emanated most intensely from 6 evenly spaced regions near the equator, like nodes on a vast circuit. When mapped in 3 dimensions, those regions formed a hexagonal grid, perfectly proportioned to the one observed during Juno's encounter. Whatever process drove the pulse now operated on a planetary scale. Astrophysicists began to whisper a new term: macrostructured emissivity. The implication? The entire surface of 3I, Atlas, might function as a single, coherent device. Its irradiated crust doubling as an antenna, a resonator, or perhaps something we had no words for yet. Then, as it neared the asteroid belt, something extraordinary happened. Dozens of small asteroids, each less than a kilometer across, shifted minutely in their orbits. Their trajectories bent, subtly but unmistakably, toward 3I, Atlas. Over the span of 2 weeks, those fragments began clustering along its projected path, as if magnetically drawn to it. None collided. Instead, they formed a trailing arc, a halo of companion debris surrounding the object, like an escort. Astronomers compared it to a gravitational wake, but the math didn't work. The forces required exceeded 3I. Atlas's estimated mass by orders of magnitude. It was not gravity pulling them, it was resonance. The same pulse echoing through Earth's systems now vibrated through the asteroid belt, tugging matter along harmonic lines invisible to human senses. 3I, Atlas was no longer a solitary traveler. It was gathering material as it came. By February 2027, its velocity relative to Earth had stabilized at 57 kilometers per second, slower than predicted. The deceleration was impossible under normal physics. Only active thrust or deliberate modulation could explain it. Infrared sensors detected faint jets of photons, quantized light emissions with no chemical exhaust, no mass ejection, only directed energy. 3I, Atlas was braking. And then, 1 month before its closest approach, the pulse changed again. It split into 2 frequencies, one continuing at 528 Hz, the other at a much slower beat, repeating once every 7 hours and 12 minutes. When translated into angular motion, that period matched the Earth's axial precession to within 0.01%. No one could explain why an interstellar object would mirror our planet's wobble. But one thing was clear. It was no longer just responding to us. It was synchronizing. Across the world, radio telescopes prepared for the final window. NASA's Goldstone, ESA's Cebreros, and China's Mian Station all locked their arrays toward a single target. On March 1st, 2027, the sky began to shimmer faintly. For the first time in recorded history, auroras were seen at the equator, waves of violet and blue rippling silently across the horizon, pulsing in a rhythm everyone by now could recognize. And then, at precisely 3:42 UTC, a burst of infrared light erupted from 3I, Atlas, spreading across the solar system like a ripple through water. It wasn't a beam, it was a wavefront. Within hours, the pulse vanished from every detector on Earth. The world went still. For 12 hours, 3I, Atlas, emitted nothing. No light, no signal, just a cold, silent body coasting toward its closest approach. And then, on the morning of March 2nd, 2027, telescopes captured something that defied every model. The object slowed to a near stop. Its velocity dropped to under 5 kilometers per second, impossible without propulsion, and the halo of debris around it arranged into a symmetrical ring. The entire structure, comet, dust, radiation, had formed a perfect hexagon. At its center, 3I, Atlas began to glow again. Not blue this time, but white, a steady, pulsating radiance brighter than Venus. For the first time, it was visible to the naked eye. People across the world stood outside, staring at a new star that wasn't a star at all. Children watched from rooftops. Pilots reported its light piercing the upper atmosphere. The pulse was gone, but the glow was alive. And beneath that quiet brilliance, instruments recorded a final, brief transmission. Just one line of binary data. When decoded, it read, "Perihelion reached. Observation complete." Then, silence. For weeks afterward, 3I, Atlas drifted past Earth, shrinking into a faint, retreating spark until it was gone. The auroras faded, the pulse stopped, the world exhaled, but the silence wasn't empty, because the data left behind terabytes of fractal harmonics, maps, and self-referential patterns contained one final layer. When analysts reconstructed the harmonics of the last transmission, they discovered that the waveform itself, its peaks, troughs, and ratios, matched perfectly the shape of human brainwave alpha rhythms. 3I. Atlas hadn't just been communicating, it had been listening, and when it left, it took an imprint of us with it. Months later, strange anomalies begin to appear again, this time not in the sky, but in human minds, because after the object's passing, people across the world start reporting the same shared dream, a sky of pale light, and something whispering through it in rhythm 42 minutes apart. By June 2027, the world had returned to routine on the surface. The skies were quiet. The headlines had moved on, but quietly, in clinics and laboratories, something was happening. Sleep researchers first noticed it. Their EEG monitors used to study dreaming began showing a recurring anomaly, a low-frequency modulation repeating every 42 minutes. It wasn't constant, and it wasn't present in every subject. Yet wherever it appeared, the rhythm was identical to the old Atlas pulse. At first, doctors assumed environmental interference, a leftover resonance from power grid harmonics or phone networks. But the signal persisted in shielded rooms, underground bunkers, even on remote islands. Then patients began to describe the same dream. They said it always began in silence, a pale horizon, a ring of light hovering over a dark ocean, and beneath it, a tone low, steady, almost kind. Some heard patterns in it, like breathing or waves against stone. Others claimed the light pulsed in groups of 12 before fading. Most woke without fear, some woke crying. A few never wanted to wake at all. When neurologists overlaid EEG data from dreamers across 5 continents, the correlation was undeniable. Their brainwaves entered phase at the same instant every 42 minutes, synchronized across time zones, distance, and language. It was impossible, yet measurable. Governments tried to keep it quiet. The International Atlas Council, still active in shadow form, issued a statement calling the phenomenon a benign neuromagnetic echo. But the public had already named it. They called it the resonance. Social networks filled with recordings of people humming in their sleep, clocks resetting themselves by seconds, compasses twitching when no magnetic field should have changed. Some uploaded audio from their EEGs. When sped up, the pattern produced the same harmonic ratios first heard from 3I. Atlas. Humanity, it seemed, was now carrying the frequency inside itself. By August 2027, the effect intensified. A small satellite array in orbit detected faint electromagnetic bursts emerging not from space, but from the ionosphere upward. The amplitude was tiny billions of times weaker than the signals 3I Atlas once sent, yet perfectly timed. It was as though Earth had become a repeater, whispering the object's rhythm back into the void. Physicists proposed the simplest explanation. The object's wavefront in March had left behind a standing resonance in the magnetosphere, a kind of planetary echo chamber now interacting with human neural fields through minute electromagnetic coupling. But that theory failed one crucial test. The rhythm adapted. On September 3rd, during a coordinated meditation study in Tokyo, participants intentionally slowed their breathing to align with the pulse. Within minutes, instruments recorded a global phase shift. The interval between each electromagnetic crest stretched from 42 to 43 minutes and 4 seconds. Every receiver on Earth changed at once. Something, somewhere, was listening and responding. The shift triggered renewed fear among those who remembered the Juno encounter. Had 3I, Atlas, truly left? Was the resonance a tether? A communication loop still open? Deep space monitors scanned the region beyond Neptune, where the object should have been, but found nothing, no reflection, no trace. Yet on September 11th, the fast radio telescope in China picked up a faint carrier signal from the outer dark. Its strength was vanishingly small, but its cadence matched the new 43-minute rhythm. The direction? A patch of sky near the constellation Ophiuchus, the same region where 3I, Atlas, had first appeared 2 years earlier. Across the planet, sleep studies reported a second phase of dreams. This time, the imagery changed. No ocean, no ring. Instead, a single phrase, repeated in dozens of languages, though never spoken aloud. Perihelion reached. Observation continues. Researchers confirmed that subjects who had never seen or heard the original transmission nevertheless reported the exact same words. Whatever had connected them transcended memory or suggestion. By October 2027, the world began to adapt to its new normal. Airlines quietly recalibrated instruments that drifted with the pulse. Hospitals designed pacemakers that ignored the resonance. Meditation groups treated it as a universal metronome, but a handful of scientists refused to move on. At the European Southern Observatory, Dr. Elena Sartre, the same physicist who had modelled the Atlas harmonics a year earlier, noticed something no one else had. The amplitude of the planetary pulse was slowly increasing, by about 0.0002% per day. At that rate, in just under 6 years, the signal would reach the same strength that Juno had recorded near the object itself. And the phase drift suggested the source wasn't outbound anymore, it was inbound. Her final report ended with a line that read more like prophecy than science. The traveller left a copy of itself within us. When the copy is complete, the original will return to compare the results. On the first night of November 2027, global magnetometers flickered, and for a brief, impossible moment, every clock lost precisely 42 minutes. When they restarted, the pulse had changed again, not faster, not slower, but richer, layered, like a chord resolving after a long rest. Somewhere beyond the edge of our system, a new light appeared, faint, steady, approaching from the direction of Ophiuchus. And as it brightened, the world once more began to hum in time. Whatever 3I, Atlas, had done, it hadn't ended with its departure. It had seeded a mirror in our planet, and now that mirror was waking up. The next observation wouldn't come from telescopes, but from within the minds already resonating to its rhythm. The light was faint at first, so faint that it could have been mistaken for a background quasar, but by December 2027, its intensity doubled every 11 days. Telescopes confirmed it wasn't a reflection or lensing artifact. It was an object, inbound on a vector nearly identical to 3I, Atlas's exit path. Only this time, it wasn't alone. Trailing the lead object were 6 smaller bodies, perfectly spaced, following in formation like moons locked in invisible tether. Each emitted the same harmonic signature that had haunted Earth's atmosphere for a year. When the data reached the International Atlas Council, no one spoke for several minutes. They all knew what those harmonics meant. The rhythm had replicated, Earth had become the seed, and something had germinated. In the months since 3I, Atlas departed, scientists had developed a new field, resonant cosmology, the study of how electromagnetic harmonics propagate through living systems. At first, it was fringe science. Then, medical sensors began picking up faint coherence in human heart rhythms, subtly syncing to the Atlas frequency. At first, only in dreamers. Then, in everyone. Pacemakers adjusted, EEGs aligned. By early 2028, almost 73% of all recorded biosignals on Earth contained the same recurring phase pattern, an entrainment that no known process could explain. Humans, plants, even migratory animals All were keeping time with something beyond the stars. The Atlas frequency had become the heartbeat of the biosphere. When the new objects crossed Neptune's orbit in April 2028, the pulse on Earth began to modulate. Its amplitude rose at precise intervals. Every time the lead object passed a gravitational threshold, the strength of the signal increased. It was as if the resonance between Earth and space was tightening, drawing both into a shared field. For the first time, the word synchronization appeared in official communiques between agencies, yet not everyone agreed on what it meant. Some scientists believed the returning formation was merely responding to the signal. Earth now emitted an automatic feedback, a resonance loop closing. Others saw something far more profound, a recall signal. 3I. Atlas hadn't left to wander. It had gone home to call others. In July 2028, the pattern reached a threshold. All across the world, auroras returned not green, but silver-white, rippling at mid-latitudes and moving like tides rather than storms. Every 43 minutes, they brightened and dimmed, in perfect sync with the pulse. But this time, when satellites passed through the luminous arcs, their instruments didn't detect charged particles. They detected coherence, an electromagnetic field structured enough to carry information. Somewhere in that light, data was embedded. When decoded, it revealed harmonics far too complex for any natural oscillation. Recursive fractal patterns containing billions of nested sequences, each shaped like the waveform of a heartbeat. The message wasn't words. It was us. At the European Organization for Astronomical Research, Elena Sartre, who had first predicted the resonance's completion, ran spectral deconvolution on the auroral data. The signal contained exactly 7.83 Hz as its foundational tone. That was the Schumann resonance Earth's natural electromagnetic frequency. 3I. Atlas hadn't imposed a new rhythm. It had amplified the one already here. Everything on Earth that generated electromagnetic fields, brains, oceans, lightning, the crust itself was now harmonized to its own global hum. Refined, clarified, mirrored. It was as though the planet had been tuned. By August 2028, the approaching formation was close enough for the James Webb Space Telescope to resolve surface details. Each of the 7 bodies emitted faint geometric reflections, identical to 3I. Atlas's crust, hexagonal, metallic, symmetrical. They weren't comets or asteroids, they were constructs. Even more astonishing, the smallest of them wasn't reflecting sunlight at all. It was reflecting the auroral emissions from Earth. Our sky was illuminating them. The mirror was complete. Then, on September 9th, 2028, all 7 objects decelerated simultaneously. Their trajectories bent inward, not toward the Sun, but toward Earth's orbit. By early October, their formation stabilized into a stationary configuration roughly 0.03 astronomical units from the planet 12 times closer than the Moon. No radiation, no visible thrust, no communication, just presence. Astronomers tracked them as they hovered in perfect silence, each one locked in phase with the global resonance. For 3 weeks, nothing happened. Then, at 3:42 UTC on October 31st, the same timestamp as the first Atlas brightening 3 years earlier, the sky ignited. From every major city, the auroras flared so bright they cast shadows, and in that light, humans across the world began to hear something impossible, not through radios, not through speakers, through thought. A tone inside the mind, layered, harmonic, wordless but intelligible in meaning. Witnesses described it not as sound but as recognition, like remembering a song you never learned. EEG scans taken during those hours showed unprecedented global coherence. Billions of brain waves phased together, forming synchronized bursts of 528 Hz, the same tone once measured from 3I, Atlas's crust. The human nervous system, at planetary scale, had become an antenna, and through that antenna, something spoke, not in language, but in emotion, warmth, curiosity, a feeling of observation, without judgment, then a message, not heard, but understood. You have completed your reflection. Now observe yourselves. At that moment, every telescope trained on the formation saw the same phenomenon. The 7 objects brightened, then slowly drifted apart, arranging themselves into a hexagonal lattice, spanning nearly 1 million kilometers, each point reflecting sunlight toward Earth, converging into a single, coherent beam of soft white radiance. Inside that beam, no transmission existed, only silence, perfect and total. For 6 minutes, the beam held steady. Then, one by one, the objects dimmed and vanished, fading not by distance but by phase transition. They didn't fly away, they slipped out of resonance. When the light faded, so did the auroras. The global brainwave synchronization ceased. Instruments went still, but the Schumann resonance, the planet's natural electromagnetic heartbeat, remained subtly higher by 0.04 Hz, a shift never before recorded. It was permanent. Humanity waited for days, then weeks, for something to follow, but nothing came. No signal, no pulse, no light, only a calm, pervasive sense that the cosmos itself had exhaled. And then, one morning in late November, Elena Sartre received a private transmission from the Goldstone Deep Space Network, a residual signal captured hours after the final flare. It was short, simple, binary again. When decoded, it formed 2 words: Atlas closed. No one ever learned whether 3I, Atlas, and its kin were machines, messages, or memories. But long after they vanished, the resonance remained woven through our world, faint, omnipresent, impossible to erase. And in quiet moments, when the night is still and the air hums just right, some say you can feel it again. A heartbeat, older than the sun, counting quietly beneath our own. Winter settled quietly across the northern hemisphere. No new signals arrived. No auroras flickered at the equator. The world appeared to exhale a long, collective breath after years of tension. But in that calm, something subtle began to emerge. At first, it was geological. Sensors buried deep in the crust, those used to monitor seismic pressure, started to hum at a faint, steady frequency, 7.87 Hz. The Atlas shifted Schumann resonance, now woven through the planet's magnetic field, had become self-sustaining. Then the biological readings followed. Seeds germinated faster in laboratories shielded from ordinary EM interference. Algae cultures exposed to the 7.87 Hz. Tone produced unexpected luminescence, glowing with the same pale blue radiance once seen around the interstellar object. No one could explain the reaction. The frequency was far too low to trigger chemical fluorescence. It was as though life itself was remembering a pattern. By January 2029, an entire of fact, the generation of researchers had pivoted toward the study of harmonic biology. Governments funded new centers not to look outward, but inward toward the resonance now looping through every living cell. For the first time, humanity's most advanced observatories were pointed at Earth. Under microscopes, neural tissues showed microcurrents oscillating in lockstep with the planet's field. When mapped, those currents formed spirals identical to the geometry once observed on 3I, Atlas's crust. Our neurons were beginning to mirror the pattern of the traveler. It wasn't infection. It wasn't control. It was assimilation by resonance, a synchronization of information, not matter. Philosophers began to ask the question scientists couldn't. What if consciousness was never meant to be isolated? What if interstellar civilizations didn't build ships to cross the void, but signals capable of transforming the listeners into receivers? In that light, Atlas closed, no longer, sounded like an ending. It sounded like a handover. The first tangible proof came from orbit. In April 2029, a CubeSat launched by university students detected a strange echo while passing over the Indian Ocean, a faint ping every 42 minutes, bouncing between the ionosphere and the satellite's hull. When the data was translated into waveform, it produced the same nested spirals found in the Juno recordings. But there was a difference. Embedded within the harmonics were new frequencies, never observed before, ones that corresponded exactly to human alpha, beta, and theta brain bands. The planet wasn't just repeating 3I, Atlas. It was elaborating on it. Across cultures, a quiet unity began to grow. Not political, something subtler. Global surveys showed unprecedented synchronicity in sleep cycles, creative bursts, and even collective moods. When the resonance intensified, hospital cardiac monitors recorded fewer arrhythmias, traffic accidents dropped, and dream journals described similar imagery, fields of hexagonal light drifting over calm seas. No one called it paranormal anymore. It was simply the Atlas effect. In June 2029, a final anomaly occurred. The Lunar Reconnaissance Orbiter, still active after more than a decade, captured a new reflection on the Moon's far side. A circular patch, 4 kilometers across, glowing faintly at 528 Hz when measured in radio frequency. No probe had landed there, no impact crater existed, but its geometry matched the Atlas hexagon ratio precisely. When ground-based antennas aimed at it, the signal they received was faint but distinct, an interference pattern shaped like a heartbeat. The Moon had joined the resonance. From that moment, humanity stopped waiting for contact, because it had already happened, and not through messages or artifacts, but through synchrony. 3I. Atlas had turned the solar system into an instrument, and Earth was its resonant chamber. Every storm, every flash of lightning, every heartbeat now carried a trace of the same harmonic code, a universal metronome pulsing softly beneath everything alive. And though the constructs were gone, some nights radio astronomers still detect a whisper from Ophiuchus, a gentle 528 Hz hum that rises and fades every 42 minutes. Each time, it ends with a single binary phrase: observation continues. Epilogue Whisperfield. Today, children born after the Atlas event grow up hearing stories of the blue auroras and the hum that united the world for 6 years. Most think it myth, but occasionally, when storms gather over the equator and the air tastes metallic, they look up and see thin ribbons of silver light weaving across the sky, and for a few quiet seconds, the world falls into perfect rhythm again. Somewhere, far beyond the edge of the sun's influence, a small object drifts through the interstellar dark. Its crust is still hardened by radiation, its glow long faded, yet deep within, a single harmonic remains, an echo of Earth's frequency, pulsing outward into the void. 42 minutes on, 42 minutes off, the universe listening to itself breathe. At first, no one cared about the anomaly. The second bloom had unified every known world. Ships glided effortlessly through harmonic corridors, colonies flourished, and humanity lived in a golden age of resonance. The small irregular beat buried deep in the spectrum seemed like a footnote, an artifact of calibration, a relic of pre-Cantus noise. But there were always listeners, the same kind of people who had once stared at faint light curves and found meaning in their flicker. On the moon city of Seren, orbiting the twin suns of Arcturus, a small group of physicists and historians began to study the irregularity. They called themselves the Sunward Circle, a quiet order of researchers who believed the universe never spoke without purpose. For decades, they gathered data, filtering the anomaly through every known algorithm. What they found defied mathematics. The anomaly wasn't random, it was recursive. Each time it appeared, it carried a slight shift in phase that, when accumulated over centuries, began to form a secondary structure hidden beneath the harmony of the second bloom. It was subtle, elegant, and deliberate. The shape that emerged was not a spiral this time, but a helix, a spiral with memory, turning not only outward but inward upon itself. The pattern resembled DNA, or the magnetic braiding of solar filaments, or perhaps the double helix of thought itself. It was motion that remembered its past. The Sunward Circle published their findings quietly, expecting interest from the academies. Instead, they received silence. The great institutions of the age had grown complacent. Harmony had become dogma, and the idea that something might exist beyond the second bloom was viewed as almost heretical. But in small rooms, on ships far from the centers of power, the data spread like rumor. Pilots began to whisper that the harmonic corridors felt different now that the paths between stars hummed with a faint, secondary vibration. Some said it was the pulse of creation renewing itself. Others said it was 3I Atlas, still whispering from beyond the edge of time. On the 2000th anniversary of the comet's first observation, the sunward circle gathered on CERN's high observatory plateau. Their instruments, ancient but precise, pointed not toward RS-79 or the Cygnus Rift, but toward the inner system of Sol, the place where the story began. The sun, though distant, still burned with the same restless heartbeat of magnetism that had once pushed Atlas into brilliance. And as the observers aligned their harmonic filters to the ancient frequencies, something stirred. For the first time in millennia, the signal returned to its origin. A faint pulse, sunward and soft, rising from within the star itself. It matched the helix pattern perfectly. The meaning, if it had one, was unclear, but to those who watched the graphs trace their glowing loops, the implication was staggering. The sun had learned the song. Across human space, instruments confirmed it. Every harmonic relay, every resonance array tuned to Cantus frequencies, detected the same modulation, a slow, sun-born rhythm, winding itself around the stable lattice of the second bloom. And though it followed the same mathematical logic, this new resonance carried warmth. It wasn't cold, uniform vibration. It was uneven, alive, fluctuating like breath. Philosophers called it the third bloom. Scientists avoided naming it at all. Whatever it was, it changed everything. Communication systems built upon the perfect ratios of the second bloom began to fluctuate, not failing but adapting. Messages arrived before they were sent. Ships reported hearing whispers, tones that mapped perfectly to their own thought patterns, as though the cosmos was anticipating rather than responding. It was as if the universe had learned empathy. On CERN, the sunward circle realized the helix pattern could not have originated solely from stellar activity. It required feedback input from all nodes of the harmonic lattice. In other words, every act of resonance across human space, every vibration from every relay, had been teaching the universe how to learn. They presented their findings to the Central Assembly of Halcyon. The ruling council, built on centuries of comfort within perfect order, refused to believe it. The chairwoman of the assembly declared, "The universe does not think, it reflects." But then the sky itself answered her. That same day, every harmonic relay across the network emitted a burst of synchronized energy, a single wave that washed through space like a breath drawn inward. For one moment, all resonance ceased, and then came 3 pulses. Not from a star, not from the lattice, not from any machine. From everywhere, from the fabric of space-time itself. 3 pulses, then quiet. The pattern that had begun with a comet millennia ago had completed its circuit, returning home to the universe that had birthed it. The perfect equilibrium of the second bloom dissolved into something deeper, more intimate. Humanity had not been teaching the cosmos to sing, it had been reminding it how. When the silence returned, it wasn't empty. It was full, a fullness that felt like understanding, though no one could translate it. And for the first time in history, not a single person in the inhabited galaxy spoke. They simply listened,